Hello, vanakkam, welcome, bonjour, hola, namaskar, sat shri akal, marhaba. Hello, Yash, Thalapati, Komal, Zil, Yogita, Niveta, Vinit, Mr. VJ, Priti, Vetrial, Soundarya. Good evening, Bachalo. Good evening, warriors. Today's session is all about derivations and the formulas of all the term 2 topics for your physics board examination, CBSE. And all of this with me, Shreyas, your physics master teacher at Vedantu, and I'm going live. So let's begin this awesome session by first of all smashing the like button. And if you're not yet subscribed to the English medium channel of Vedantu, guys, you need to do it right now. Sri Krishnan, I think I saw you just few days back, but nice to see you back too, bacha. And guys, there is also the Telegram channel link which is there in the description box. Make sure you check that out as well. So let's have a look at all the students out here, and let me also show you all the links right over here. Hello, Swagat Ahe sir. Dhanresh, looks like you're from Maharashtra. Hi Amrita, hi Arsha, hi Vasumati. Hello everyone. Nice to see you guys. Now you can see the links are right over here. If you have not seen, please look at it. Mock test 1 link, please give it. Mock test 2, mock test 3, free mock tests available for you just for your CBSE Term 2 board examination. Okay, solutions also I'll put it up soon, don't worry. And in case you have solved the papers, just mark the answers and keep, so that you can check the solutions and know what are the mistakes. This is the link of the Telegram channel. It works. Just click on it. You will see the Telegram channel will open up, and all the other crash course details, any other course that you would like to enroll yourself into, JEE crash course and the NEET crash course of course is right over here. Make sure you check it out. Alright, so let's begin with the class. And today's class, like I told you, is all about derivations and formulas, and I have some awesome mind maps for all of you. Hello Kritika, hello Shreyas, hello Nivedita. Okay, vanakkam guys. Now IIT Roorkee, IIT Madras, both are good guys, so don't worry. IIT Roorkee and Madras both are awesome IITs. Just go with it. You should get your branch, that's all. Now in electromagnetic waves, what are the important things that you need to study? First is the source of the electromagnetic wave. Second is the equations and the characteristics and the nature of the electromagnetic wave. The third thing is the electromagnetic spectrum, the different kinds, its application, the sources and the wavelengths. So I have made a beautiful mind map for all of you. So in the source of electromagnetic wave, what and all you should know? Yes, Adityas, you can let me know. Okay, so field created by Maxwell and wave propagation by Hertz. These are the two main concepts. Even if you open up NCERT, right, you will see the same thing right over here. So I don't know whether I have it open. Let me just see. Looks like I have closed it. Okay, anyways, so guys, the idea over here is that Maxwell gave the theoretical approach, right? He talked more about the theory about electromagnetic waves. Hertz was the guy who made experiments, who conducted experiments and found out that light is actually an electromagnetic wave. Maxwell told that electric fields can create magnetic fields can create electric fields. So he gave the relationship between the electric and the magnetic fields. He also told about the moving charge, the concept of moving charge, which creates electric field as well as magnetic field around it. Very important concept. So a normal charge which is at rest creates electric field, but the moment you move the charge, it also produces magnetic field. So if you oscillate a charge, you will notice that you will eventually end up creating an electromagnetic wave. This was the conceptual part, but that actual part experimentally was given by Hertz. That's one thing. Now the next thing, yes, that's the Maxwell's equation. This mind map is going to be very useful. You can take a printout or you can draw it the way I have shown, and then you can add more formulas. Don't worry, you'll get the entire PDF in the Telegram channel. If you have not joined it, please join it right now. Okay, now the next thing, this session will be for at least 2 hours, I guess. The next thing that you should know over here, let me just get my pen. All right. Okay, so talking about electric and magnetic field waves, these electric and magnetic fields are basically perpendicular to each other. Like you can see, they are perpendicular, and the direction in which they move is also perpendicular to the electric and the magnetic fields. So going back, E and B fields are perpendicular. Not just that, E cross B is parallel to the speed of light. So if electric field is this way, magnetic field is that way, E cross B using your right hand thumb rule will give you the direction of light. So there could be questions based on this. They will give you direction of E, they'll give you direction of B, and they'll ask you where is C. Example, just think about it. Say electric field is in I cap direction, magnetic field is in J cap direction. I cross J is going to give you K hat. So the light will go in the Z axis. That's what. I hope this is clear, everybody. All right. So let's move to the next part. Oh, somebody saying I missed UV rays. Thank you very much for pointing it out. So let me add UV rays. Thank you guys. Yeah. So I don't know how it got missed, but yeah, let me put it over here. UV rays as well. This is also there. Okay. Now going ahead, there is relationship between electric field, magnetic field and the wave speed. That is something which you should talk about, and let's write it down. And how is speed and frequency related? Very important formulas. Observe this carefully. Speed of light is electric field by magnetic field. It is also electric field amplitude by magnetic field amplitude. It is also 1 by root of permittivity into permeability and permeability of the medium. This is also frequency into wavelength. This is also omega by k, which is angular frequency by angular wave number. So this formula sheet is very important. You don't know what might be given, what has to be found. You can use these formulas whenever required. So this is basically your amplitude of the electric field and magnetic field. This is basically your property of the medium, the medium's electric permittivity and magnetic permeability. This is frequency, this is wavelength standard. Omega is 2 pi f angular frequency. K is your angular wave number, so it is 2 pi divided by lambda, standard values. E and B are the instantaneous values. If you notice, this value of E is nothing but E naught sine or cosine, whatever you want to use, kx plus minus omega t. Same way, the value of B is B naught sine or cos, whatever you want to use, kx plus minus omega t. One doubt I have, let's see, one question rather. Is it mandatory to put kx first? Can I put omega t first and write omega t plus minus kx? Think about it. Thank you, Vidyashar Bose. Ida oru bro nyenga. Oh my god. Is it mandatory? Anything can come. How many marks will derivation come for board exams? For major marks, at least 10 to 15 marks minimum. I'm telling you, minimum 10 to 15 marks. Derivations or derivation related questions. Okay, so this is something which you should know. Also, you should know one simple logic, and that logic is the medium decides the wave speed. The source that is generating it decides the frequency. These together decide the wavelength. So wavelength is decided in the end. Source decides frequency, the medium decides the speed, and together using this relationship f lambda is equal to c, you will decide the wavelength. Last thing is the energy of the wave. Energy of that wave is divided equally into electric and magnetic fields. It's equally divided. Both the fields carry equal amounts of energy. So whenever the total energy is asked, it is just the sum of the electrical and the magnetic fields energies. You do not have formulas for the CBSE board exam, so let's not worry about that. Yes, lens maker derivation can come, and I'm going to derive it today. Okay, now let's go on to these points. Radio waves, micro, infra, visible, UV, X-rays, gamma rays. So you should know application for each and every one of them. Let us see, what do you know about UV rays? Whatever you know, write it down in the chat box. I want to see how many of you remember randomly, out of the blue. UV rays. What is the wavelength range? In what range does it lie? What is the wavelength above or below? And what are the applications, phenomena? Are there some problems with that? Okay. Yes, phase difference is k into delta x. Okay. So, sorry, 2 pi by lambda. Yeah, which is k into delta x. Okay. Used to kill germs. Yes, UV rays are very harmful. They can damage your skin, can cause cancer, skin burns, and the UV rays are protected. I mean, you get yourself protected from UV rays by applying some lotion or through the ozone layer. So the ozone layer becomes small, then the UV rays from the sun will definitely damage you. Now, the range of UV rays, well, you can see it's above the visible rays. So it's going to the higher frequency. It is more energetic than visible rays. It's higher than violet. Violet has a wavelength of 400 nanometer. So the wavelength is lesser for UV rays. So it is less than 400 nanometers. The ultraviolet radiation lies in between 400 nanometers and angstroms. Reason being, X-rays, the wavelength is in Armstrong. Recollect, X-rays, Armstrong. How do I remember it? X-rays is used in diffraction. It's used to study solids, and the crystal structure undergoes diffraction when X-rays are passed through it. So you will see that diffraction occurs only when the wavelength is comparable to the intermolecular gaps, or the spacing between them, and the spacing is usually in Armstrong. So now I know that X-rays are in Armstrong. So that's how you are supposed to remember, through examples, through some stories, through some applications. Gamma rays used for treating cancer, microwaves in your microwave oven, infrared, it's created from your body, greenhouse effect. All these things should come in your mind. Visible rays comes from 400 nanometers to 700 nanometers. 400 is violet, 700 is red. Red is longer, blue, violet is shorter. Radio waves is used for long distance communication, satellites, radio, your TV, your all these long distance communication. Radar happens through radio waves. Okay, so I have put up a table, uses, range, type of radio wave that we are talking about, type of electromagnetic wave. I put this, but you have extensive paragraphs. And guys, in the Telegram channel, if you have not seen, please see that I have put up underlined NCERT. I have only underlined and given it to you. What more you want? It can't be, simpler than this. The entire PDF of NCERT with underlined pointers for each, not just here, but the entire chapters, for all the chapters of term 2, it is there. So please check it out. So this is the most important graph, most important diagram which you should know. Obviously, please don't carry color pencils and say, sir, do we need to carry 7 color crayons in the exam? No, you just have to make a chart, just mark. Okay, gamma rays, X-rays, ultraviolet, violet, yellow, red, infrared, microwave, short radio wave, long radio wave. You should know it. No problem, Bhargav, always for you. Sir, radar system is for microwave. Nah, sir, you said radio waves. Radar comes in between. Radar comes somewhere in between. You'll see in between radio waves and microwaves. So it's on the higher end of microwaves. It's on the lower end of the radio waves, short radio waves. Okay, whatever the major derivations are travel with Afzal, I'm going to do it. So should we remember the wavelength in terms of 10 powers, or like nanometers is better? And who is that? Anabalgam Anbu, because remembering in the powers of 10 is more difficult, no? So you can remember some in Armstrong, like X-ray in Armstrong, visible light in nanometers. Radio waves are very long, so in kilometers, meters, so it's easier that way. Okay, I left AM waiver. Oh my god, guys, no, guys, in radio wave, one of it is AM, one of it is FM. So AM is not a special kind of wavelength. Please don't get it wrong. Like microwave, radio waves, X-rays, AM is not a separate wave. AM is a type of process on that wave which makes it amplitude modulated. So you will see that in communication systems. It is frequency modulated and amplitude modulated. AM is not a separate kind of wave. AM is an application. The velocity of all the waves is same. Basmati, all the light waves travel at the same speed. Yes, we'll be doing VIT EEE also. Which ray is used for satellite detection? These radio waves, this range. Questions are based on frequency also. See, Hari Harsan, simple. If you know the wavelength, you can find frequency. If you know frequency, you can find wavelength, because F into lambda is C. C value is simple, 3 into 10 to the power 8. So if you know the wavelength, you can easily find the range of frequency. So only remember one of them. If you try to remember both, good chance you might just forget it in the exam. No need to memorize critical. That's why I told wavelength is easier to memorize. I feel so. For you guys, is it easier to memorize frequency or wavelength? You guys only tell me. Kritika, you only tell me, is it easier to memorize wavelength or frequency? I feel wavelength is easier. Acha, Anirudh remembers both for electromagnetic. Good. If you remember both, you have excellent memory skills. My memory is not that great, guys. Okay, wavelength. We know the velocity is lambda by t. Velocity is lambda by, lambda into f. So if lambda is different for different radiations, how come we say velocity is same? Frequency is also different. Bhargav, that t is different. So what did I tell you just some time back? Look at this. Medium decides speed, not wavelength or frequency. Source decides frequency, wavelength is decided in the end. That's the reason. Understood, bacha? I'm very good. Sriji. Nice to see you back again. ARDV, like I told you, use the tricks. Okay? Radio wave long, meters, kilometers. Long radio waves, kilometers. Short radio waves in meters, millimeters. Then you get micro. Micro is in milli to micro. Infrared is in just above that 700 nanometer mark. 400 to 700 is a very important data point range. Above that, you get your ultra. Then X-rays is in Armstrong. Gamma is obtained from nuclear reaction. So nuclear means, see, nucleus, what is the size? 10 to the power minus 15. So it will be very small, 10 to the power minus 12, 10 to the power minus 14, 10 to the power minus 15. So it's in that range. Keep that in mind. Okay, bacha? Where do we find our NCERT underline notes? Samyukta Kanan, go to the description box, Telegram channel link, click open Telegram. If you have not downloaded Telegram app, download it. In that app, just scroll up. I have just put it up just yesterday. Next. Now this is the difficult part. Relation between E and B, derivation, no, don't expect it. It will not be there. In fact, Janaya studies, I doubt they will ask any tough questions on E and B relationship also. So don't worry. Bohr's energy level derivation can come, Anisha. I will be doing that. This is for class 12th passing out batch. Prem Kumar, in a live class, let me just see if 2x speed is available. I'll have to move like this. I'll have to do like this. I'll have to write like this. If this is 2x speed. So you press 2x speed, I will write like this, okay? This is live class, bacha. Sorry, 2x speed is not available. In the recorded version, it is available. Alright? Okay. Come on. Let's start with the derivations first. Reflection laws using Huygens principle. Can I teach derivatives? Swati, derivatives is not there. 11th standard. Okay. No voice? What are you saying? There should be voice, Sandeep. Refresh. Huygens principle, reflection laws. Let's start. First draw a mirror. Obviously reflection means mirror only, row. So first draw what? Mirror. Next, what will you draw? Incident rays. So draw incident rays. Incident rays. Can you wait a minute after writing, Angel? I want to keep it fast because there are so many things, but Angel, I'll tell you, whatever I write will be available to you in the PDF. I will post the PDF immediately. You don't even have to wait 1 second. You can make fast hand notes. Show incident rays. These are your incident rays. Show this AB. AB is called, AB will be now your incident wavefront. It's your incident wavefront. Now, when the wavefront reaches the mirror, this point starts creating secondary waves in this direction, opposite, because it's a reflector. Meanwhile, B will reach here, reach this point. So by the time this point reaches here, this point creates waves in this direction, and that's how the wave reflects. So you will see this will be the reflected waves. Probably this will be the reflected wavefront. I will call this CD. So CD is your reflected wavefront. Now observe this. Let's start drawing the angles. Obviously, to draw the angles, you should draw the normal. So let us draw the normal. Fair enough. Next thing, mark the angles of incidence. This is the angle of incidence. Normal, incident ray, angle of incidence. If this is angle of incidence, think about it carefully. This angle will be 90 minus I. Perpendicular, na? Complementary angles I, 90 minus I, complementary. Understood, guys? Sandeep, PDF will come after I write it. Guys, you don't understand the concept of time, kya? Only after I write the PDF will come. Before writing, how will the PDF come? Hold on, na? Let the lecture get over. PDF will come on Telegram channel. Okay, next. This is I. Why is this I? Come on, this is 90 degree. This is 90 minus I, this is I. Obviously, got it. This is 90 minus I, this is I. Fair enough. This is one side. Next thing, over here for the reflected rays. Why am I showing you all this? So that you revise. Even if you know this, even if you feel that this is simple, still revise. Don't be overconfident. You will suddenly get confused in the exam. So over here, this is the reflected angle. If this is the reflected angle, this entire thing is 90 minus R, because this is 90 degree, the blue lines. So this is R, this is complementary angle. Now, if you look at these two yellow lines, these are totally 90 degrees. The angle is 90. So if this is 90 minus R, this is R. Fair enough. Now what will I say is that in the time point B reaches C, that distance BC, which is speed into time, that distance BC is basically BC, speed is speed of light, time is t. You will notice the wavefront generated at A will reach D. By the time B reaches C, point A will generate a wavefront which will reach point D. So the wavefront generated at A reaches D. So therefore distance is speed into time, speed is c into t, ct same, hence I can clearly say BC is equal to AD. Now this is a very important relationship, because if BC is equal to AD, these are two right angle triangles, notice 90 degree, 90 degree, into right angle triangles, one side is common, and I also said the other two sides are also congruent. Obviously, the triangle ADC is congruent to triangle CAB. These two triangles are congruent. Now the moment, yes, SAS congruency test. Now the moment they are congruent, that's it, their angle should be equal. So which angle will be equal to what angle? This angle of this triangle should be equal to this angle of this triangle. So hence I will be equal to R. So that's what you get. That's all. That's the end of the proof of law of reflection. Very good. Unfortunately, we cannot post it on the description box, Bhuwana. Just download the app, Telegram app, Bhuna. It is very simple, easy, low weight app, very light app. Just download it. It is going to be very useful for you, trust me. Telegram is a very good app, better than WhatsApp. Very secure, very safe also. Okay. Okay. His interference of thin film is not present, bacha. Don't worry about it. Next derivation, guys. Let's move on. So we have to be very quick. We have to be, very focused today, because it's just 2 days before the exam. Okay. So number one. Number two, if you feel that something you did not understand, please ask. I will see if I can answer. I'll try to answer. But you can watch the replay later on. You can definitely understand it. Let me tell you that. Okay. So here in refraction proof, you need two mediums. This is medium 1, this is medium 2, refractive index. Here the speed is v1, so v1 will be c by mu1. Here the speed is v2, so it is c by mu2. speed of light is different in different medium, and that constant is called as the refractive index. So the amount by which, or the factor by which, your speed decreases, that is the refractive index of that medium. If I tell you the refractive index of the medium is 2, that means the speed will become half. If I tell you it is 1.5, then speed will become 1.5 times less as compared to in vacuum. Okay, let's start drawing the incident. This is the incident rays. This is the incident wavefront. So this is A, B. Obviously this is perpendicular. This is how the rays are coming. All right. Now let's also draw the normal. Let's draw the normal right over here. Okay, fair enough. And then next will be obviously showing it little bit bent like this. It bends. This is your refracted angle. This is your refracted wavefront. This point I'm just going to call it as D. If this is R, this is also R. And over here, if this is I, this is also I. Okay, as simple as that. Incident angle, refracted angle. Now again, you should start your derivation by saying AB is your incident wavefront. Then your D, oh, did I not mark that point? Let me call this DC. Okay, so DC is your refracted wavefront. Also, I will say that when the wavefront reaches this interface, the boundary of the two mediums, then you will see when the wavefront has reached here, this point will still travel with this speed. Point B reaches C. Point B reaches C with speed v1, and in the same time, you will notice that this point generates new wavefronts in the newer medium, this medium, and you will notice those wavefronts will reach this point. So by the time B reaches C, you will notice these wavefronts reach over here. So you will see the wavefronts created at A reaches point D, but with a different speed v2. Now think about it. Distance is speed into time. Speed into time. So AD will be v2 into t, whereas over here distance BC is nothing but speed into time again. But that speed is different because medium is different. It will work. The insane, just replace the t without, instead of t use telegram.me. It will work. Young's double slit experiment also I will take, Thalapathy, definitely. What is WF? Oh, that's wavefront, guys. I wrote short form. I thought you will understand. Okay. So anyways, WF Jania studies is wavefront. Wavefront. Will they ask these two derivations? They can, definitely. Kalyani, if we have enough Marathi crowd, I would love to take the classes in Marathi. एकदम मजा येईल मराठीत. एकदम आता माझी सटकेल मस्त मजा येईल. Okay, but I'm not sure how many people would love to learn in Marathi. If we have, why not? I would love to teach in Marathi too. तुम्ही पण महाराष्ट्राचे आहात का? हो, मी महाराष्ट्राचाच आहे, पुण्याचा आहे मी धर्मेश. अच्छा, चलो. Let's see the next one. Now, once you get this right, the next concept is somehow proving Snell's law. And Snell's law has sine, so sine of the angles. So sine of the angles. So let's see how do we do that. Let's figure this out. This is I. Naturally, this is 90 minus I. If this is 90 minus I, this is I. Okay. Complementary is the same angle. Similarly over here, this is R. This is 90 minus R. Naturally, this is R. R, 90 minus R. Complementary is the angle back again. I am tired, but Yogita, your exams are there. So if I rest, then it will not be good for you. So I am working hard only for you guys. Let me tell you that. So now what we'll do is we'll try to find out sine of I and sine of R and see what it is. So sine of I by sine of R. Sine I is opposite by adjacent. Opposite is BC. Adjacent is, sorry, not adjacent, my bad, hypotenuse. Opposite by hypotenuse. Hypotenuse is AC. So AC comes over here. For sine R, opposite is AD. Opposite is AD. Hypotenuse is again AC, like you can see. AC cancels. So I get BC by AD. But wait a minute, BC by AD. BC is V1T. AD is V2T. TT cancels, so it will be V1 by V2. But wait a minute, V1 and V2 is written right over here. So this shall be C by mu1 by C by mu2. CC cancels, mu2 goes on the top and mu1 comes below. Now cross multiply. So mu1 sine I is equal to mu2 sine R, which is your Snell's law. Done, done, done. Understood, guys? Clear? Everybody understood? Sir, is V1 in air equal to C? Yes, V1 in air, Ishwar, will be equal to C. Definitely Kalyani. Okay, hence proved. Yes, Indrani. Hence proved is very important. Hence proved. You feel so happy when you write that hence proved. Okay. Next, interference and intensity. Wow, we have gone to wave optics interference part. Can we use pen for diagrams? I doubt. Please don't use pens. Use pencils only. This is from rare to dense. But for dense to rare also, what will change? Tell me. What will change? Tell me what will change in the entire derivation. Nothing. Only the diagram will change. Here it is bent like this, there you will bend it like that. I don't know why NCERT did it. They have drawn two diagrams, 2 times they have derived. I think they were short of some words. They wanted to just fill that textbook. Their head would have told, you have to write compulsorily 10 pages for this chapter. So not derivation for rare to denser, dense to rare. So random it is to confuse you. Okay, clear? No problem. Achha, they didn't derive, but they told it. Achha, they have not derived. Thank God they didn't derive it. But I remember seeing 2 paragraphs. One was for rare to dense and dense to rare. Okay, optical instruments, telescope, everything is coming, guys. Hold on, everything will come. Let's start with this. Many of you might not know these derivations. Let's do this first. First, we have 2 waves combined together which are in phase. That means they are in sync. If they are in phase, what you get is a big wave, constructive interference. The amplitude is A1 plus A2. This is called as constructive interference. Similarly, if you have one wave and another wave exactly opposite, that is called out of phase, then combining them together, you get a smaller wave whose amplitude is A1 minus A2. Such a phenomena is called as destructive interference. Next thing, if you take any wave, you will see the intensity of that wave is proportional to the amplitudes. Which power? Half, 1, minus 1, 3, 2, what is it? I'm going to go derivations chapter wise, but Mariam, let me tell you, derivations are only there in waves, atomic structure and ray optics. That's all. Yes, very good. Square. Excellent, all yours. That's the answer. But now, what if you have a wave like this and the other wave is not in line with it, it's slightly ahead of it. There is something called as the path difference. So the delta x is there. Now this path difference means they are neither in phase, they are neither out of phase. It's something else. So what you get, the outcome, is a new wave. This is your resultant wave and some new amplitude. I don't know, I'm just going to figure that out. And you will see this is neither constructive nor destructive. It is called as intermediate interference. It is called intermediate interference. Dual nature, little bit here and there. Little bit. Small things are there. Okay. Now this path difference creates something called as the phase difference. in phase, out of phase. Crest, crest, trough, trough, in phase. Crest, trough, trough, crest, out of phase. Crest, nah. Trough, nah, nothing. So it's something else. So it is definitely going to have some phase difference. I can also call it delta phi, and delta phi everybody knows is 2 pi by lambda into delta x, standard formula. Now, after you see this, there is one more thing which you need to know. That is, if you open up NCERT also and keep it side by side, you will see one derivation for two waves of same amplitude being added, and you have to find the resultant amplitude and intensity. So there is one important derivation for two identical waves added with phase difference. So there is one important derivation, you can check it out. So basically the resultant wave, R stands for the resultant wave, is given by wave 1 plus wave 2. Wave 1, let's say it is A, you can, in books they have used cos, if I'm not wrong, cos omega t, plus A cos omega t plus phi. This is the values of the two waves. These are the two waves which you want to add. Now if you want to add these two, just realize that you are basically wanting to add, taking A common, cos C plus cos D. Cos C plus cos D is 2 cos C plus D by 2 into cos of C minus D divided by 2. So just do that. So it is 2 times cos of omega t plus phi, whole thing divided by 2 into cos of this minus this, omega t plus phi minus omega t, the whole thing divided by 2. Okay. Now when you do the math, what you will get? 2 times of A. This will be omega t plus omega t is 2 omega t divided by 2. The 2 cancels. So cos of omega t plus phi by 2. And here omega t cancels off. Only phi by 2 remains. So cos of phi by 2. Rearrange it further. So it will become 2a cos phi by 2 into cos of omega t plus phi by 2. Now this is your resultant wave. This is what is given in your books. You should know this. 2 is a constant, A is a constant, phi is also a constant, T is a variable. So whatever you see over here, this is your amplitude of the resultant wave. Twice A cos phi by 2. Hi Sandeep, welcome back. So Prem Kumar, which part you did not understand? Okay? So this is one wave, this is another wave. You can see this wave, amplitude is A, frequency is omega. This also same frequency, same amplitude, but phase difference. When you add two terms, cos C plus cos D, the formula you should know. What is the formula? I think I should put it somewhere. Cos, I'll put it here. Cos C plus cos D is 2 cos C plus D by 2 into cos C minus D by 2. You can do cos D plus cos C also, it's the same thing. Important questions, Jagdivan Singh, kal karaunga. Yes, ray optics is not done yet. Krishna, don't worry. Even if it was done, you can always go back. That's all. Oh wow. Hello Harshvardhan. Nice to see you from the JEE Fusion batch. Hope it's all going great. Now the moment you get this, there is one last relationship which you should know. That's for intensity. And the idea is like this. When the amplitude is A, let's say, then the intensity is I naught. When the amplitude is A for each wave, the intensity is I naught. If the amplitude is 2A cos phi by 2, then what is that intensity? Remember, intensity is directly proportional to the square of the amplitude. We can use sine also. Yes, sine also can be used, but in your books cos is given. So I would prefer doing it for cos. Reason being, the model answers might contain cos expressions. The examiner might see sine. He will feel that you have done wrong. See, that is the problem with boards. I don't have any faith with the person checking your board paper. Who do you know who he is or who she is? Do you know whether they will understand? Do you know whether they have that patience to check it? Do you know what kind of problems they have at home? I don't know. Maybe that person checking is very frustrated. He or she has to check some 500 papers in 1 week. So they will do it fast. He will see sine, cos. Oh, he has done wrong. Gone. So let's not take risk. Yeah. So this will be square proportional. So square proportional, guys. Square it. So if you square A, basically you will understand that A square is proportional to I naught. So 2 square A square cos square 5/2 is proportional to the final intensity. Out of that, A square is just your original intensity. So this will come out to be 4 I naught cos square 5/2. That is your final intensity. That's all. Sugita, I'm not making you feel afraid, but this is how board toppers are basically. I mean, if you want to get 98, 99%, that's how it is. Okay? Because they write ditto. And that's what you see. Sometimes many JEE toppers are not board toppers because JEE people, NEET people, what do we do? I know you're doing this, I can get it. Why do I want to hold like this? I will hold it like this only. So they go by shortest way, easy way, multiple ways. So we are more into logical thinking. We are not into that, memory based things. So don't worry. You might lose just half a mark, 1 mark. It's not like the teacher will give you 0. No, that will not happen. You might just lose a half mark or 1 mark. That's all. Devi Nandana can probably agree with me. Devi Nandana, don't you write everything, whatever is there in the book as it is. Niteshwar, please start studying now. Don't ask that question, sir, what to do? Start now. Can you use sine? Yes, bacha, you can use sine, but I am skeptical about it. If they have given cos, use cos. If they mention in the question, for sine you derive it, then use sine. Mr. Zarg, proportionality. Look at this, intensity proportional to square amplitude. So I naught was proportional to A square. So final thing will be proportional to this square. When you square this, what will happen? A square will come, but A square is I naught, so put I naught. That's all. Is that okay? Is that okay, bacha? Let's move on. Pranav Rai, this is in English. नीट में डीजी में वो हिंदी में था, इसलिए सेम सेशन दोबारा. Okay, let's do that. Even if I do d minus c by 2, how does it matter, Someshwar? Okay, guys, trigonometry. Tell me one thing. Cos of d minus c, isn't it cos of c minus d? Yes or no? Come on. Cos of c minus d, isn't it cos of d minus c? Yes or no? Someshwar and others. So does it matter? No. So trigonometry, you should know that. So I have done it conveniently because I know it will be easier. Moving on to the next one, guys. Okay. No problem. It's okay. You ask that out because these things will come in your exam and then you will get confused. Oh, why am I getting minus sign? In the Shreyas derivation, in book derivation, minus sign was not there. Now you know how to tackle that. Thank you, James Burke. Now, oh, this is done. I just did it, maxima minima. Now, part difference in a Young's double slit experiment. Now, again, if I did it for JEE, I will do it within 3-4 lines. But for boards, the derivation is completely based on algebra, Pythagoras theorem. It's not based on trigonometry. Please keep that in mind. Okay. Now, what you need to do is, first of all, there are 2 sources. Understand the process, how you have to derive. Show the 2 sources, the slits basically. This is the main source illuminating the 2 slits. D, small d is the distance between the slits. This complete thing is capital D, which is more than small d. And this is your screen. At some random point, these 2 waves meet, but they do not arrive simultaneously. There is some path difference. Only that path difference can give rise to other formulas. So the aim is to find out what is the path difference at P. Since S1 reaches earlier, S2 reaches later, so the path difference will be S2P, bigger one minus the smaller one. That's something which you should realize. Now, what is done in the derivation is that they try to find out S2P separately, S1P separately by using Pythagoras and then use basic algebraic identities like a plus b whole square, a square minus b square, a minus b whole square. These are the basic identities used. So let's do it one by one. So S2p square minus S1p square is equal to, let's try to figure this out, guys. Maybe I can write it slightly left side. I will need a lot of space. So S2p square I'll try to find, and then also minus S1p square. Let's try to figure this out. First of all, S2p. S2p is this line. So what you do is draw a triangle and look at this triangle over here. Now you'll notice that the base is nothing but d. S2p is the hypotenuse. Height is y plus this distance. This distance is half of the width between the slits. So it is d by 2. So this is nothing but d by 2. So Pythagoras, hypotenuse square is base square plus height square. So it will be nothing but base is d square plus height, which is y plus d by 2 whole square. Cool, everyone? Okay, this is first term, minus. Next term, S1p. Look at where S1p is. S1p is this one. Cool? Draw the base. Draw the height. The base is still d only. Height, this much, is y minus this much. This much is this much. This is half of d. So this is nothing but d by 2. So from y, you take away d by 2, you get the height. So that shall be d square plus y minus d by 2 whole square. Now just expand and see what happens. The first term will be d square plus a plus b whole square is a square plus b square plus 2 into a into b. Next term, okay, let me just put it in the brackets, minus, look at this one. This is d square plus a minus b, oh, I forgot that square, a minus b whole square is y square plus d square by 4 minus 2 into y into d by 2. That's the second term. Everybody fine? Oh yes, I'm the best biology, sir. Thank God. Oh my God, what are you guys saying, man? Concentrate. Now this one, if you notice, many terms are going to get cancelled. Believe me. D square, d square, y square, y square, d square by 4, d square by 4. This and this, no. Minus minus becomes plus. Be careful about it. So this will become 2y. Acha, the 2 also gets cancelled. So yd will come from here. Minus minus becomes plus. Here also you will get yd. So you will basically get 2 times of yd. Everybody fine till this point? Okay. Now the last thing is over here. S2p square minus S1p square. A square minus b square is a minus b into a plus b. Everybody knows this? So why you put S2p square? That's what you'll understand, Mr. Zerg. Why is it square? Look at this. This term on the LHS, is actually S2p minus S1p into S2p plus S1p. This is the LHS, and RHS I just figured it out. It is 2yd. Got it? Now why did I write it as square? Because this part is just delta x. This part is just delta x. This part is very easy to find. I'll tell you why. If you concentrate on this arrangement, you will realize both the sources are so close. The point P is somewhere here. This is D. This is capital D. This is your point. Be it S1P or be it S2P, roughly their lengths are D only at that point. Do you agree? Why is that? Because D is much larger than D. They are very close. So they are very close to each other. The lines are almost parallel. This line, this line, this line. It's almost the same thing. You can see that. Does that make sense? God is love. I'll be making the superhero series for all the chapters. I have told this again and again. Please keep in touch with the community posts I keep making. So now this is nothing but D plus D. This is 2yd. So d plus d is 2. So 2 times delta x into d is equal to 2yd. 2 cancels. So delta x is equal to y small d by capital D. That's it. That's the answer. That's your part difference. Got it, everyone? Trigonometry one is so much cooler and better, na? Yes, not line by line, important. All the important ones. Every line is not important, obviously. Coming Sanjit now to fringe. Fringe width. See, you asked it, it came. Evangeline, you will not need anything else apart from my marathon sessions and the assignments I gave you, the mock tests, the questions I gave you, and whatever strategy video I asked you, whatever I asked you in the strategy video, do NCERT back exercise, NCERT underline, previous year papers, solve some school papers, and then write the derivations, practice, whatever things I have told you, just follow that. You will not need anything else to score beyond 30 marks. Trust me on that. Selva Karthik, this is the CBSE derivation. If I do it for JEE, see, I'm a JEE teacher, NEET teacher, so I will do it very differently. Okay. Now, going to the fringe width part, the first thing you need to know is, okay, first of all, let me call this as Y. Okay. At any point, how do you know, or how do you locate a point which has constructive or destructive interference? That's the first thing to start with for finding the fringe width. So let's say I want to find a point which undergoes constructive interference. So what do we know about constructive interference? For constructive interference, that is basically a maxima. That is basically for a bright region, bright fringe. We know that the part difference should be how much? What is the value of the part difference? It should be any multiple of lambda, the wavelength. So it should be n times of lambda. Do you remember it? Very good, Anirudh. Yep. No, not n lambda by 2. It is n lambda. Correct. Now I know the value of delta x. So go back. Delta x is yd by d. Okay. So delta x is y small d by capital D. This is equal to n lambda. So solving it over here, y shall come out to be n times lambda capital D by small d. Done. This is the location of any bright region. By the way, similarly, you can also do it for a dark region. I'm not solving it. You can do it right now or later on. So y will come out to be n plus half times lambda d by d for a dark region. You can do it. Try it out on your own. Okay. Now, having said that, let's try to figure out what is the fringe width. So it's very easy. So let's say this is your nth fringe, nth bright fringe, and this is your n plus 1th bright fringe. This will have some coordinate yn, and that will have a coordinate yn plus 1. This is third fringe, this is fourth, this is fifth, this is sixth. n plus 1th. So what is the meaning of a fringe width? Fringe width means from one bright to one bright, or from one dark to one dark. You find any two distances, it is the same thing. So this is beta, which is your fringe width. So fringe width beta shall be yn plus 1 minus yn. Obviously, this is this minus this. From this, if you take away this much will be remaining, which is your fringe width. So substitute now. N plus 1 will be n plus 1 into lambda d by d. This n, if you substitute, it will be n times lambda d by d. Okay, this is equal to beta. So therefore, beta will be equal to, you can see, n lambda d by d plus lambda d by d minus n lambda d by d. These two cancels. So you will be left with lambda d by small d. That is your beta. Sorted. Mistake at the constructive. Why? What is the mistake, bacha? Everything is fine. Prem. Any crash course available for me for Vedantu only for physics? Only for physics is not available. It's physics, chemistry, maths. Physics, chemistry, biology. You take it up for all the subjects. Don't think that I have to only attend physics. You never know how you will use the other three subjects, other two subjects. And plus the mock test is very important, which you can give, at your convenient time and do the analysis. All right. Independent of the nth value. Yes, all the, you should know the difference between Young's double slit experiments interference pattern and the single slit diffraction pattern. Over here, the intensities are decreasing, same or increasing as you go from one maxima to other maxima. 2n plus 1 by 2 because n starts from 0, usually, Hari. Selva, I would not prefer to solve it by a method. It all depends on the examiner. Why take risk is my question. I lost marks in board exam because I was preparing for JEE. Yes, Saundara, correct. Very good, Kaushik. It is same. Intensity is same. In single slit diffraction, the intensity reduces. If they ask fringe width, should we prove it from YDSE? Abhinaya, it depends on the marks. So let's say, for example, it comes for 2 marks. If it comes for 2 marks, you will start by saying, we know that delta x for bright fringe is this and y is given by this. Hence, beta is this minus this. Solving, you get this for 2 marks. If it is for more marks, 4, 3, like that, then you have to probably start from here. See the marks and then solve the question. Okay, cool. Angular width is similar, guys. I mean, you can just do this part like this. If you take any fringe, right, over here, any fringe, it will subtend some angle. Let's say this is delta theta. This is the fringe width. This length, you can roughly take it as d. This is like your arc. This is like your radius. This is like your angle. And we know what's the relationship between length of the arc, radius and angle. Obviously, just use that. So beta will be radius into theta. So you can find the angular width. Is that understood? As simple as that. It's very easy. Okay. Cool. Let's move on. Yes, obviously, Shravana, if you are deriving it using trigonometry, if you don't mark theta, then how will the examiner know? Come on. See, always think that you are deriving it for a 9th or 10th standard student, your younger classmate. Just, one of my student told me that whenever he used to derive, he used to think that he's deriving it for his crush. He had a crush on some 10th standard girl. Imagine this. So he used to always think, I'm deriving it for her. So nice statements he used to write. Very nice, explaining body. Very neatly labeled diagrams. So he used to think of his crush and write the exam paper. So cool, right? Motivation. He did not go out with his crush, but that's a different story. But he got good marks. Okay. Now, please don't say, sir, I don't have a crush. Whom do I crush? Sir, and what is a crush? Okay, let's go on. Now, okay, let's do this. Next part, this is the slit width, A. Reoptics derivation tonight, everything, Prithvi, whatever is going to happen, the entire party is tonight. The whole party is going to be tonight, okay? Now, screen. Alright, this is center. Now, what do you get is that when light goes through a slit, it bends, it spreads, and it creates an interference pattern just like YDSE, except for the fact that the widths will be different and also the intensities keeps on reducing. Now, talking about the fringes again, let's say this is a bright fringe. This is a bright fringe. Again, this is a bright fringe somewhere here. Again, a bright fringe over here. Wow, so cool. Okay, these are all bright fringes. Now, in between there will be dark fringes. This is your dark fringe. if you want to locate the theta for a dark fringe, then the formula is theta is equal to lambda by A. This is for a dark or a minima. For a minima, this is what it is. Okay. Apart from whatever derivations I am doing, nothing else will come, AR Devi. Okay. These are the most things. Prem Kumar, my crush is physics. That's very good. And your name is also Prem. Very nice. Now, the next thing, theta for maximas. This theta for a maxima. To locate it, this theta, you will put n plus half lambda by A, and this is your dark or this is your bright fringe. These are the formulas which you should know. There is no derivation in this. Be thankful about it. The derivations are crazy for this. Okay. Now, having said this, you can also find the width of the central maxima if you would like. So, if somebody asks you to find the width of the central maxima, this is also there in your books. So, what you should realize is for a central fringe, for your central fringe, it is exactly in between the first dark fringe on the top side and also the first dark fringe below. So, in order to figure out that angle, this complete angle delta theta, the angular fringe width of single slit diffraction pattern, you should realize that what you actually need to do is just draw a horizontal line, divide it into two equal parts, and each one of them is the angle for minima. This is theta and this is also theta. This is theta, this is also theta. So basically your delta theta will be nothing but 2 times of theta, and each of the theta will be oh, I forgot that n over here. So sorry guys, my bad. Any nth fringe. So that n has to be there. If I don't put n, it is only the first dark fringe. So it will be nothing but 1 into lambda by A. So it is basically 2 lambda by A. So this is the angular fringe width of the central maxima. Oh, no, Anirudh, A is not the distance between the slits. Read it. Single slit. It's only one slit. It's the width of the slit. Be careful. This is the slit width, not the distance between the slits. Got it? We are going to come to that, Sarvari Srinivas. Is it necessary to mention that theta if you are using this kind of derivation? Yes, you should. Show it. You should learn all the diagrams, Nada. Nada, come on, bacha. Already you are learning only the term 2. Imagine last year or next year students are going to learn the entire 12th standard physics. Plus in the term 2 also you are seeing only 70% syllabus. 30% is already cut. Now in that also you want important means. Yeah, in some formulas they mention n minus half because for them Ashwin, the n starts from 1. If n starts from 0, it is n plus half. So if it is 0, lower number, you add it. If it starts from natural numbers, not whole numbers, then you put minus. That's all. Yeah. Width of central maxima and angular width. Yeah. Width of central maxima is different. Angular width is different. Width means the actual distance. So once you know delta theta, you can find the width. The actual width. So that width will be this d into delta theta. Width is in meters, millimeters, nanometers, whatever. Angular width is in radians or degrees. Can we use 2n minus 1 instead of n plus? Yeah, you can use. So why twice in Vedantu? Sandeep, that was done in Hindi. This is an English medium channel. That's the reason. Okay. Obviously, I'm not a fool to do it twice. So this is for all the English medium students. That is for all the Hindi medium students. Yes, you should. Okay. Let's do the next derivation. Okay. Now, Let's start this. First of all, this is one of the most important and lengthiest derivation. All other derivations are smaller than this. This is a derivation for a curved surface, refraction formula. What's the formula? If you remember it, please put it up in the chat box. Mu2 by V, remember, mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. So that is the formula which you need to use, which you need to derive. Now, how are you going to derive it? Let's figure it out. See, the whole idea is that the angles are going to be small, and when the angles are going to be small, we can use small angle approximation, which looks something like this. Sin theta is roughly theta, which is roughly tan theta. This is something which should be there in your mind. Since the rays are getting refracted, that's why I'm thinking about sin I by sin R and all of that. And I think I'll be also using tan formula somewhere or the other for trigonometry perspective. What should come in your diagram? Observe. Show a curved surface. Show one side is rare, one side is dense, whatever. Assume the refractive index N1, N2. Then show the ray coming from object. Draw a normal. Wherever that normal intersects the axis, that becomes your center of curvature. This becomes your radius of curvature. Cool? Next. What is the next thing? You will mark all the base angles. This side, and this side. All the three base angles should be marked. All the three base angles should be marked. Need not be alpha, beta, gamma. You can use your own symbols also. That is okay. Okay? Don't have to mark in the same order. You can mark this as beta, this as gamma, this as alpha. It's okay. Okay. Now, this is object distance, this is radius, this is image distance. That's something which you realize by now. And the next thing you should do is find the tan of alpha, gamma and beta. This is the first thing you are going to do. So let's start with it. First of all, for tan of alpha, look at this triangle. You will realize that tan alpha is nothing but opposite, which is NP, divided by this one, which is OP. Now, tan of small angles, these angles are very small. So small angles tan is angle itself. So this will be alpha. Similarly, let's try to look at gamma. So for gamma, look at this triangle. You will notice that gamma, which is roughly tan gamma, tan gamma is roughly equal to opposite NP by adjacent PC. NP divided by PC. Next is this big triangle over here. Okay, that's beta. So beta is roughly tan beta, which is nothing but NP by PI. So it will be NP divided by PI. Fair enough, guys? Normal and center of curvature, no. Normal is perpendicular. The normal will pass through the center of curvature, and the line, which is the normal, which passes through the center of curvature, will also include the radius, because radius of any arc or circle is along the normal only. Okay, next thing. What you should do is, I think we'll have to use some exterior angle properties and all of that. So let's write it on the next slide maybe. So exterior angle properties for which triangles? Observe. First is this triangle. In this triangle, this is exterior, these two are internal. We know the exterior angle property. So exterior angle is the sum of interior angles. So exterior angle is I is equal to alpha plus gamma. Not just that, there is one more triangle which I want you to see, and that is this one. For this triangle, this plus this is gamma. So R plus beta is gamma. So therefore R is nothing but gamma minus beta. Now why did I do this? Because I and R are incident and refracted angles, and I can make use of sin I, sin R and all of that, and also approximate angles. So using Snell's law now. So now let's use Snell's law and see what do we get. So Snell's law. So sine of I by sine of R is equal to sine of alpha plus gamma by sine of gamma minus beta. But sine of angle is the angle itself when the angle is small. So this will be alpha So this will be nothing but alpha plus gamma divided by gamma minus beta. And what is sin I by sin r? That is nothing but your mu2 by mu1, of course. Mu2 by mu1, or you can call it n2 by n1, because mu1 sin I is mu2 sin r. That's the formula. Is that clear? Now it's simple. I'll tell you what you need to do. Just multiply it. So mu1 into alpha plus gamma is equal to mu2 into gamma minus beta. Now substitute all the values from before. So start substituting. Mu1 alpha, see from before, what is alpha? Np by op. So Np by op, just substitute it. It is nothing but Np by op. Then check what gamma is. Check what gamma is. Gamma is Np by Pc. Gamma is Np by Pc. So it is Np by Pc. So this is mu2. Again, this is Np by Pc. Last thing, beta. What is beta? Beta is nothing but Np by Pi. So this is Np by Pi. You will notice from everywhere Np will cancel. And what is remaining over here is just the object distance, image distance and the radius. That's all. Trust me on that. So let's figure that out. What is object distance over here? U is technically minus OP because this is negative side, this is positive side. Light rays are going this way. R is technically plus PC and image distance is technically plus Pi. So substitute it over here, and that's it. You will get the answer. Okay, what you're going to do next is just substitute. So mu1 by 1 by OP, instead of OP you are going to put minus U plus 1 by PC. PC is nothing but R is equal to mu2 into 1 by PC, which is R minus Pi. Pi is nothing but V. So 1 by V, and from there you will get your answer, which is mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. Done. Okay. Sir, how to plot alpha, beta, gamma? What do you mean by alpha, beta, gamma? You can choose anything, whatever you want. You can choose this as alpha, this as beta, this as gamma. Alpha, beta, gamma are the base angles of all the rays: incident, refracted and the normal ray. These are the three angles. With sign convention, yes, you have to substitute with sign convention. If you put plus OP, you will get a wrong answer. You will get something else and then you will start wondering. So be careful with the signs. Okay, cool. Now lens maker formula. Should we draw all the three diagrams? No, I don't think so. I'll show you what and all diagrams you need to draw. So first thing is for lens maker. Lens maker as in you want to find the focal length. So if you want to find the focal length, obviously the object is going to be at infinity. So the rays will come from an object at infinity, of course. And I want you to treat a lens like two surfaces, curved surfaces. Surface here and there, surface 1 and surface 2. So this happens to be your first surface, which will probably have some radius of curvature. I'll just call it R1. And you will also have this curved surface, and this is your second surface. This will probably have some radius R2. Okay, R1 and R2. So it's basically 2 times you have to apply that formula, nothing else is there. So let's apply this one by one, and we are interested in finding out the focal length. So this is your focal length. This is your focal point. This is your focal length. So let's do this one by one, starting with the first surface. Using mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. What is mu2? Mu2 is the refractive index where the refracted light enters. This is the incident medium. It enters inside the glass. Just look at this ray which is inside. We are talking about this ray. It's inside glass. So mu2 will be mu. V, I do not know where is V, because after it gets refracted, I don't know where it forms an image. Should we write the assumptions? Yes, write the assumptions. Okay, so if you observe carefully, this ray over here is inside glass. Actually, it would have gone and met somewhere over here. This is this point which I have shown over here is technically your image from first surface. This image from the first surface technically becomes the object for second surface. Keep this in mind. The ray bends, it wants to meet here, but that image becomes the object for the next surface. Okay, so now let's start writing things down. V is V1, I don't know where it is formed, minus mu1 is incident medium's refractive index. U, object distance, rays are coming from infinity, so do not forget to put infinity. Mu2 minus mu1, so mu minus 1 divided by R. R is nothing but R1. Okay, this is your first statement. So mu by V1 minus 1 by infinity is 0, so is equal to mu minus 1 by R1. Now do the same thing for the next surface. So for the second surface, do write the same thing. So mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. Now for the second surface, second medium is air. So mu2 will be 1. V is where the final image is formed. That means the final ray meets at the focus. So this should be focal length minus mu1 by U, mu1. Okay, mu1 is this glass medium because this is the incident ray for this second surface. So this should be mu. Object distance, remember the object for the second surface is the image from the first surface. Image. So it will be just V1 is equal to mu2 minus mu1, that means 1 minus mu divided by the second surface. Now what you're going to do is just take this and this and just add them. Just simply add. That's it. That's all you need to do. This is the derivation method, A.R. Devinanda. They have substituted infinity in the end. That's the only difference. What I have done, I have substituted infinity before only. If you open up NCERT also, you will notice they have first written general formulas before and after, and then what they have done is they have substituted infinity and then they have substituted image distance and all of that. This is fine. It's okay. There is no problem in this derivation. You will get marks. Let me tell you that. Yes, you have to write for the first and second surface. And lastly, they have substituted V as F. See the derivation, you will see. Yeah. So add them, now you will get the answer. That's it. So 1 by F minus mu by V1 plus mu by V1 is equal to mu minus 1 by R1 plus 1 minus mu by R2. And therefore these two people cancel, so 1 by F is equal to, take mu minus 1 common, so it will become 1 by R1 minus 1 by R2. That's it. That's the lens-maker formula. We don't need to use sign convention because I have not substituted the value of R1. R1 is just left untouched. If I put R1 as something like minus ON minus O, I don't know, PC, something like that, then I have to put plus or minus. R is a variable whose value needs to be substituted with sign. So I don't need to put plus or minus R1. No, that's why Yash, I'm not substituting minus R2 and plus R2. Getting it? No need of minus. That is why don't use that complete derivation of NCERT. It is very confusing if you see that. Yes, I know in NCERT, what was the use of sign? You tell me that. Because while using this formula, what they have done, I'll tell you what they have done. They have put some numbers or some alphabets, AP or PI or something like that. Okay, they did all this. Here also they have put the radius of curvature is some alphabets, AB or CD or something. Again in the end, they wrote that AB, CD, PI, whatever back into R1, R2. So they put and again took it back. No use. Over there we needed it. Over here we needed it because, say, over here, all the trigonometric formulas, whatever I wrote, where is that trigonometry? Trigonometric formulas they had some variables like PC, OM, distances were there. So in order to convert the distance into the optical terms, U, V, R, that's why I substituted with sign convention. Yeah. So that's why CBSE students face a lot of problems. More problems, you know who face? NEET and JEE students. Why? Because JEE students, NEET students, they study in such a simple manner. You open NCERT and then you're like, oh my god, what is this? Okay, now I'll tell you what. See, this exact same derivation, whatever I taught you now, the same, not this one, sorry. This one. The same derivation works for lens formula. V1 is not F, V1 is the intermediate image. V1 is the image by first surface. So first image is formed somewhere else, the next image is formed at the focus. 2 times refraction happens. Keep this in mind, 3G. First refraction is not going to give the answer. Second V is the F. Okay, now the same derivation works, I'll tell you why. Because instead of assuming the object at infinity, you assume the object somewhere. You assume the object is somewhere and the image is not formed at focus, the image is formed at some V. It's the exact same derivation. That's all, you will see now. HK, R1 and R2. What is R1, R2? R1 and R2 are the radii of curvature of the surface. Wherever the light hits first, that becomes your first surface. The other one becomes your second surface. If you draw that line, draw that curve, you will see it's a circle. Center will be here. So this is the radius of curvature. So this is R1. R2 is the radius of this curve. So this is R2. So for the first surface, when I use this formula, I put R1 because for this surface, I have to use this R1. For the second surface, this is the radius. So that's why I used R2. Is that making sense? Does R2 always negative? No, R2 is not negative always, Prem Kumar, because if you take a concave lens, what will happen? R2 will be positive, R1 will be negative. Got it? So don't by heart like that. Yes, before starting the derivation, just mention in brief and start the derivation. Key. This is focal length, this is the distance, this is object distance. So mention all that. Yeah, mention all that. Thank you, Anisha. Yeah, underlined PDF will be, Jania, it is already uploaded. NCERT is already uploaded. Only this will be uploaded after the class. I hope all your doubts are clear. Okay, now for lens formula, I don't know. Shanti, you just see my method, it is so simple. The same method. Now, if you guys understood this part, now you will understand this part also. It's so easy. Trust me on this. What you need to do, assume that the object is here. Assume the object is here. This is your object distance, U. Okay. This is your first surface. This is your first surface. The rays from the object will come here. Then inside, they will obviously refract. They will refract. And again, they will come out. So maybe some other color. Okay. Like this. This is where the final image is formed. And this distance is V. And this surface is your second surface for refraction. Observe this carefully. It's the same thing. This is for the first surface. For first surface, if you write mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. Mu2 for this surface is this medium, glass medium. It's entered inside glass. So mu2 is glass refractive index. V, I do not know. See, the ray after going inside, I don't know where it wants to go. This is your V1. This is your V1. This is that intermediate image. So basically this is your V1. Next, minus mu1. mu1 is incident rays in air. So put 1. Object distance is U. So just put U. Mu2 minus mu1, U minus 1. R will be this surface's radius. First surface radius is R1. Now, for the next surface, for the second surface, what you do, use the same formula. Again, mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. Check one by one. Mu2, second medium, this medium, air medium, it has come outside, so 1. V is the final image distance, which is v itself, minus mu1 is the glass, it's inside the glass first, so 1. U is the object distance, keep this in mind. This image becomes the object for the next surface. This image becomes the object for the next surface. I will do that, Thalapati Vijay. Is that clear? Is that making sense? Yes, for semiconductors also it is there. Okay, so basically this U will be V1. This is the most important part. The image of the first becomes the object for the second. That's all. This image becomes the object for the next surface. That's it. Now this will be, oh sorry, what the hell did I do? Mu2 minus mu1. This is supposed to be mu. Oh, sorry, my bad. Mu1 is whatever is there is inside. This will become 1 minus mu divided by radius. Radius is nothing but r2. That's it. Radius is r2 because this is the second surface. Done. Now just again add it. Nothing else is there. Just add the two. Adding. Just add the two and see what do you get. Mu by v1 minus 1 by u plus 1 by v minus mu by v1 is equal to mu minus 1 by r1 plus 1 minus mu by r2. This is what you get. Now solving, you will get the final answer. Mu by v1 will get cancelled. So 1 by v minus 1 by u is equal to, this is nothing but mu minus 1 is common, 1 by r1 minus 1 by r2. Now what is this? This is focal length. So this is 1 by f using lens maker formula. So that's it. That's your lens formula. Sir, V1 will be before the final image because the second surface ray will go away. Matlab that's okay. This is just for your understanding. Kaushik, don't worry about it so much. Sir, for atoms lesson, will they give atomic number in the question? For simple elements like hydrogen, helium, lithium, don't expect. For some other elements, yes, they will. Yes, U1 will become U in the second surface. Yes. Refracted ray not parallel to the principal axis. No. It's just, I've shown it random diagram, so don't take it to heart. Sir, is it really parallel? No, it is not parallel, guys. It's some random ray. Okay. Yes, this is exactly the proof for lens maker also, no? See, what was there? First surface, second surface, add, you got it. In this case, first surface, second surface, add, you get it. Same derivation is there. Only difference is, in lens formula, object is randomly placed, image is randomly placed. In lens maker, object is at infinity, image is at focus. That's all the differences. See if you guys got it. Can we move ahead? Okay. Some basic formulas over here for magnification. Let's see this. Magnification, it's image height by object height, which is just V by U. You should know this formula, of course. If M is positive, it means it is obviously erect, and if M is negative, then it is inverted. And magnitude of magnification, if it is more than 1, it is enlarged. And if magnitude of the magnification is less than 1, it is diminished. That's all. So these are some basic pointers which you should know. Apart from that, the power of the lens is 1 by f. F is in meters, power is in diopters. Very good. Yes, there could be different methods, Sriram, but you don't have to use random methods. Use methods which are exactly equal or similar to CBSE methods only. Okay, can we go ahead? I think you, okay. All right, Harshint Pro. Now, prism derivations. Tomorrow I'm going to give all the important questions from all the chapters in one shot. And prism, what are the important derivations? First, angle of prism, incident angle. Some books use E, some books use I2, but I think we can use I2, that's okay. This is internal refracted angle. This is your internal refracted angle R1, R2. The dotted lines are the normal, of course. So first thing is finding the relationship between these angles, and the best way to do that is something like this. If this is R1, this is 90 minus R1, because this whole angle is 90 degree. This is also 90 degree. So this angle is 90 minus R2. Now, in order to find the relationship, the first thing you should focus on is this triangle over here. This triangle over here. In this triangle, if you notice, sum of all the angles of a triangle is 180. So sum of all the angles of a triangle is 180. So what do you get? This plus this plus this, 180. Come on, let's do that. So A plus 90 minus R1 plus 90 minus R2 is equal to 180. Okay, so basically what do I get? A plus 90 plus 90, 180, minus R1 minus R2 is 180. So A is equal to, shift these two people there, 180, 180 cancels, is R1 plus R2. This is your first result. Hello Matesh. Yes, this is not minimum deviation, Sharvana. This is not minimum deviation. Please note that. Yeah. Okay. Next thing. These are generic formulas. This is not for minimum deviation. Wait a minute. We are going to come to that. Now, the next thing is deviation. Now, for deviation, you should know that the initial ray was going like this. So it deviated by delta 1 here, and this ray was going like this, so it deviated by delta 2 here. So if you notice, this whole thing is your final delta. This is your initial delta, this is your final delta. And for refraction, deviation is always I minus R modulus. You should know this formula. It's very obvious, because if you draw the normals, it is seen that the deviation always is the bigger angle minus the smaller angle. That's all. Now, thin lens in contact ARGB, that's a very simple derivation. You can just have a look at it on your own. Okay? It's very similar to just like adding the powers using this guy's image is that guy's object, this guy's image is that guy's object. Just do that. It is very similar. So that's not very important, but that is very simple also at the same time. Okay. Now over here, what you can do is the total deviation, this whole deviation is this plus this. So it is delta 1 plus delta 2. Now delta 1, this deviation is this angle minus this angle, big minus small. So it is I1 minus R1. Delta 2 over here is big angle, I2 minus small angle. So it will be I2 minus R2. So I1 comes together, so it will become I1 plus I2 minus R1 and R2 come together, but I already know this is A, so this will be I1 plus I2 minus A. That is your delta in general. That's all. So these are two important derivations based on geometry. You can get it, but probability for this is less, but it's very easy to remember, very easy to do it. Now comes the minimum deviation part. Okay, now for minimum deviation, this diagram is slightly wrong. Let me tell you that. Actual diagram should have been that, the ray is parallel, but ignore that part. So I don't know, I will have to close it again, edit it and all of that, but just please understand that this should be parallel to the base. This is your base. It should be parallel to the base. For minimum deviation, we are talking about minimum delta, minimum deviation. So when minimum deviation happens, what you will see is this angle and this angle are equal, these two angles are also equal. So basically I1 is equal to I2, R1 is equal to R2. Also, what you can do is, since R1 is R2 and we know R1 plus R2 is equal to A, R1 or twice R1 is A, or R1 is just A by 2. This is one thing. Second thing, here you can see delta is I1 plus I2 minus A. So I1 and I2 are equal, so 2I1 minus A. So basically I1 will be A plus delta 2 comes below. These are some tricks which you can use for solving the problems. Now there is one last formula over here which is for refractive index. Refractive index is sin I by sin R. Refractive index is sin of I by sin of R. Now just substitute it. Sin of I means this one. So it will be sin of A plus delta by 2, and this is nothing but sin of R1, which is nothing but just A by 2. So this is that formula again which you should know, but here the delta is only minimum delta. Minimum delta, least deviation. This formula also gets approximated for thin prism. For thin prism. For thin prism, angle A is small. All the angles are small. So when all the angles are very small, what happens? Sin theta becomes theta. So you will see mu will be equal to, numerator will have A plus delta m by 2 divided by A by 2. 2 cancels. So it will be A plus delta m divided by A, cross multiply. So mu A will be equal to A plus delta m. So delta m will be what is it? A into mu minus 1. That's the answer. You have to substitute it with the sign convention, Mr. VJ. Is that okay? You cannot substitute it directly. You have to substitute with the signs. You'll get wrong answers, not just wrong in sign, but also wrong in magnitude. Matesh, solve more mock test. See your weak points. Wherever your weak points are there, attend those classes. Watch the recordings of those classes. Okay, cool. How many times have I read NCERT? Many times, yeah, I don't know. Lost count now. Okay, now most important derivations. Will I go for the graphs as well? Syed, I have done the graphs, in the one shots just in the last few days for all the chapters of Term 2 Physics. Please go through the graphs, PDFs you download. Whatever graphs I have done over there, whatever graphs I have underlined and I told you please go through it, only those graphs you do. That's all. Formula sheet, whatever I write will be available. Now, what you need to do for simple microscope is that, first of all, remember that the ray diagram is such that you place the object between the focal point and the lens so that the image is enlarged, virtual and erect. So this is where your object will be and much before the focal point, and what you will notice is that probably your rays go like this. Oops, sorry guys. I'll probably draw the image first, that is always easier. Okay, so one trick of ray diagrams is always show the image first because you know where it is, and then draw the ray diagram. Don't show the focal point and all those things. It becomes easier. How many of you do that? Please tell me. Isn't it easier that way? So that you don't have to use too much of your brains now. Okay. Now you can show more rays and all of that. That's okay. Alright. So you can show even more like this because it goes like that and all of that. Okay. So this is your ray diagram. This is where your eye is present. You are holding the magnifying glass very close to the eye. That's what it is. And this angle over here, this angle, I will call it theta 1. Theta 1 is the angle subtended by the image. You can see that it is by the image for an aided eye. Aid means help. You are using magnifying glass. With the magnifying glass, you are seeing it big. So that is the angle which the image subtends at your eye. Diffraction syllabus is not there. So guys, remember one thing. if you hold an object close, the angle which it subtends increases. Now, if I observe this pen using a magnifying glass, it will look big. So that's the angle subtended by the image of that object at my eye. Everybody clear about this? Next thing is, if you hold this object at a distance of d from your eye, which is unaided. This was for an aided eye, in case you are not able to read it clearly. I'll write it over here. Image by aided eye. This, if you notice, this is unaided eye. This will subtend some angle. I'll call it theta naught. So theta naught is basically the angle subtended by object by unaided eye. Now if you take the ratio of these two, that is called as the magnifying power. What is that called? That is called as the magnifying power. Imagine if I hold this pen, it subtends 2 degrees angle. It subtends 2 degrees angle. I put a magnifying glass, suddenly it becomes 10 degrees, huge. So 10 by 2, which is 5. So that is called as the magnifying power. Got it? Everybody? No, Salva, I did not eat dinner. There is nice fish which is cooked at my house, and I'm going to have the fish after the session is over only. Okay? Thalapathy, if you solve the mock test, then see where you went wrong, analyze the mock test. Just see those questions. Write it. Practice those questions 5 times. 5 times. Okay. Now what you need to do is that, the final image is formed at D. Now we are going to talk about the magnifying power formula for these things. Okay? So we are going to just derive the magnifying power formula for these things. So let's try to figure these bits out. First of all, where is it? Yeah, magnifying power is this by this. So therefore, magnifying power, since it is theta 1 by theta naught, can I not say theta 1 is image height, or I can say it is roughly equal to tan theta 1 by tan theta 2, which is roughly equal to opposite by adjacent. Opposite is image height, adjacent is D, and tan theta 2, it was not theta 2, it was tan theta naught. Tan theta naught is object height by adjacent. So object height by adjacent side, which is D, so which is HI by HO, which is just your magnification. So the magnifying power comes out to be magnification of that lens for, least distance of distinct vision. This diagram is enough. If you draw diagrams, you will get half a mark. If you complete the derivation, then you will get all the marks. Now, what you need to do next? Magnification is V by U. So you are trying to find out the magnification power. So V by U, I can write it as V into 1 by U. Now 1 by U, think about it using lens formula. What is lens formula? Come on. 1 by V minus 1 by U is equal to 1 by F. So from here you will get 1 by U is equal to 1 by V minus 1 by F. Rearrange, that's what you get. So you put 1 by V minus 1 by F right over here. Now solve this further. So this will become nothing but 1 minus V by F. Last step. What is V? Image distance. Where is the image? Image is formed at D but negative D. Look at the sign convention. D is distance. D is distance. So 1 minus D by F. So that will give you 1 plus D by F. That's your magnifying power. Got it? Now the last thing over here is, if at all they ask you for magnifying power when the image is at infinity, it becomes very simple. You can read it also, you will understand it very easily. Logic is the same. Angle subtended when you take the help of the glass, magnifying glass, upon angle subtended by without the instrument, without anything, without any help or without any aid. So just do the same thing, you will get the answer. It's very easy. What is D? D is least distance of distinct vision. So this is the formula when you are holding it at the least distance of distinct vision. That formula d by f is when you are using it under normal or basically relaxed condition. The eye is relaxed, then the image is formed at infinity. Image is formed at infinity. Got it, guys? Done, done. Can we move ahead? Important derivation. I hope this is entering your head. Okay, tomorrow at the same time, 7:30, guys. Yep. So correction. Did I not write 1 plus d by f? Oh, sorry, that line looks little bit longer. I meant 1 plus d by f. Yes, thank you. It's only there here, 1 plus d by f. Got it, guys? Alrighty, moving on to the next one, compound microscope. So in compound microscope, what you need to realize is the object is placed near the objective lens. This is called as the objective lens. And you have the second lens which is close to the eye. That's why it's called as the eyepiece. And this is called as the length of the tube. This is called as the length of the tube, meaning distance from one lens to the other lens. Now, in the arrangements that is given in your textbook, the only one arrangement that you have is when you place this object at the focus of the objective, very close to that. So when the object is very close to the focus, image is formed very far away. In fact, so far that it forms very close to the eyepiece. So you will see that the intermediate image that is formed, is formed almost here. This I will call I1. This is your intermediate image. Very close, very close to eyepiece. Very important. And this becomes the object for the eyepiece lens. That is the first thing you should keep in mind. Accordingly, you draw the ray diagram. Don't draw ray diagram and then figure out where it will land. Draw this and then show the ray diagram. Like this. Okay, like this, and then show. Okay, this way. Show the rays later on. Draw the images, objects first. Now, what you should remember is that the eyepiece actually acts like a magnifying glass. For a magnifying glass, where do you place the object? There is hardly anything left, I'll tell you, Mr. Zerg. After this one, telescope is there and two small things to, I'll take a maybe 2-3 minutes break and then we'll continue the rest. Yeah, the binding energy calculations, I don't think the quantitative aspect is there. Yes, between focus and object, between focus and pole, not O. Focus and pole. You place the object between focus and pole so that the image is enlarged. Now the exact same thing you do over here. You make sure that this image lies between the focus and the pole of this lens. So this eyepiece actually acts like a magnifying glass. So the focal point is somewhere here. So this is the focal point of the eyepiece. What you will see is an extended image right over here maybe. So this is your final image. You can obviously draw the ray diagrams. Like this. This is your ray diagram. That's it. Done. Show more points. Obviously, whatever is there in your NCERT book. I've given you the idea. Now you can complete the ray diagram. Now, here is the final verdict. Observe. This image is formed very close to the eyepiece. So, first time, because of the objective lens, the magnification is given by V by U. V is the almost the tube length. It's almost this distance, L. So I can almost put this as L. U is exactly this distance, so it is basically minus FO. Minus FO. Do you guys understand it? Why it is minus FO? Oh, no problem. Optical center. Okay, fine. Optical center is also okay. Cool. So this is minus FO because this is the object distance. I've just mentioned it over here. Second thing, what I'm going to do is, for the magnifying glass, that is basically for the eyepiece, We know the magnifying power. Magnifying power depends whether it is 1 plus d by f or just d by f. This is Fe, depending on whether it is least distance of distinct vision or whether it is relaxed vision. Your eyes are relaxed. So accordingly we will use this. So your total magnifying power of your microscope turns out to be just this into this, nothing else. Just this into this. That's all you need to remember. So for example, relaxed condition, it will be nothing but L by F naught, minus sign is there because it is inverted, that's all, otherwise it's fine, into D by Fe. This will be for your relaxed condition. That's what is there in your books. It's a multiplication. Total magnification is this by this. V is L. Look at this. The image distance. Look at this. What does this mean? When I wrote this statement, what does this mean? The image is formed very close to this. So image distance is roughly equal to L. And when I wrote this object is at F naught, what does this mean? U is roughly minus F naught. That's what I've substituted. In NCERT the minus sign is not indicated, then you also don't indicate. But actually the image is finally inverted. The image is inverted. Is that okay, Prem Kumar Thalapati? Okay. Rahul Krishna, ideally it should not be there, but I am just doing that, mass defect related problems just on the safer side, because they have given just the qualitative aspects of it. I doubt 90% it should not come, 10% we are not taking chances. Yes, so the tube length will be roughly, actually the tube length is image distance of the objective lens plus object distance of the eyepiece, but this is roughly equal to V only because the image is formed very close to the eyepiece. That's the reason for that. Now for astronomical telescope, how you should draw the ray diagram. Starting with object at infinity. Object is very, very far, that's the only difference. So the rays will come from very far away distance like this. If the object is at infinity, where will the image be formed? Obviously the image will be formed at the focal point. So the image, but this is intermediate image, will be formed the focal point of this guy. What is this guy? This is your objective, at objective. Now this part of that lens, which I call it again the eyepiece, eyepiece again acts like your magnifying glass. Keep this in mind, there is no difference. Again this will act like your magnifying glass. Object is placed between focal point and the pole, so the image is enlarged, virtual and erect, but already the image is inverted, so it will become big over here. So you will notice that your final image, will be formed very, very far away. This will be your final image at infinity, very far away. And if it is forming at infinity, that means this object which is there should be very, very close to the focal point of the eyepiece. So FO is also here, FE is also here, very close to each other. Is that understood, guys? What happened? I'll repeat. Object was at infinity. So where will the image form? At focal point. Now, the final image also forms at infinity or very far away. So this point should be the focal point of the other lens. So this is very close to the focal points of both the lenses. Clear, guys? Distance between object and eyepiece lens is called as the tube length. Yes, Sharvana. Now I hope that is clear. Okay, VO plus VE is the exact value, but remember we did an approximation that the image is formed very close, so we've ignored that object distance UE. So U is 0, roughly 0, hence we get it roughly equal to VO. Okay. Now let's have a look at this. So this length of the tube, since this is both the focal length of this guy and this guy, so this will be roughly equal to F naught plus Fe. F naught plus Fe. And the last thing is magnifying power. Magnifying power is F naught by Fe over here. This is something which you should know. This is for normal adjustment. Image is formed at infinity. Keep all these things in mind. In telescope also the length is technically the length, see this is approximate. Length is exactly equal to where the image is formed. Where is the image formed? At V. Image is formed here from the objective lens plus object distance from the eyepiece. This is exact value. But VO is roughly FO, UE is roughly FE. That's why this formula comes. Now this final image is inverted, so you can also put a minus sign because of the inversion. That's all. Yes, NCERT exercise questions are needed, ARDV Nandana, definitely. Wow, we have come to electrons now. Can we take a 2-minute break, 2-3 minutes break, so that I'll also refresh my throat. Oh my God, where is this? Three-minute break, so okay, starting now. Okay guys, so let's be back. Okay, what about derivations of Einstein's photoelectric equation? I'm doing that. सर परीक्षे पत्रिकेवर चर्चा करण्यासाठी परीक्षेनंतर थेट सत्र असले पाहिजे. हो, नक्की असणार धर्मेश. परीक्षा झाल्यावर 1 तासाने मी लगेच मिळणार आहे तुम्हाला, भेटणार आहे तुम्हाला. वी आर बॅक. येस, Yeah, let's do this. Reflecting. Oh, reflecting telescope and all that is not there, guys. Yeah. NCERT. Don't solve all the NCERT questions. Do only the ones which are in the syllabus. Okay. Thank you, Shreyas V, so much, and nice to see you. Somebody from my, sharing the same name. Biconvex, plano-convex. See, biconvex, plano-convex. Biconvex means two sides convex, bulges out. Plano means one side plane, one side convex. Plano-concave means one side plane, caving. Cave means it's depressed inside. Biconcave, cave means it's depressed inside. Bi means two. That's all. Thank you, Nisha. Sigma male. Wow, what kind of names, man. Alpha male, sigma male, delta female. Someday I had, during our times it was alpha male. Now your generation is sigma male. I think by the time you guys grow up, it will be like Omicron male. We'll have Omicron males, na? Omicron is also the series of alpha, beta, gamma, delta. Which side is plane on plano-convex? You can take any side. You place it like this or like this. It does not affect anything. Focal length remains the same. So the orientation of the lens does not matter. Keep this in mind. Everybody has Renuga, CBSE as well as your Tamil Nadu board students. Hi Sriram SSP, I'm very good. Oh, that's Hulk, is it? Full wave and half rectifier working alone, explain. Ajay, can you do one thing? Can you just watch this video? I've explained it right over here. Where is it? On our channel, just go over here. Just only one small part. Okay, just go over here to videos. Where is it? Oh, sorry. It's just go to community. My bad. Oh my God. I put it somewhere. The link. I don't know where it went. The link. Oh my God. I'll have to search for it. Or best, just do one thing. Just search here. That's your Shimon sir. Semiconductor. He's holding a pen. Okay. So semiconductor, just search for it. Just go over here. Do you see this? 0 to superhero. You can watch this or this or this. In that, just watch that replay. That's all. It's a small part. Okay. You will be able to do it. Just search for semiconductor. That's it. Okay. Wow. A.R. Devi Nandana. Oh my God. You are in Sankalp NEET JEE batch. Wow. Nice to see all of you out here. Okay. Which side is plano-convex plane? Will it affect? No. Prem Kumar. Whether you put it like this or whether you put like this. I know R1 and R2 will change. R1 will be R in second case. R2 will be infinity. In second case, R1 will be infinity. R2 will be R. But the signs will also change and the final focal length remains the same. It does not get affected. Okay. Now let's go to photons and all of these things. First is the properties of photons. You should know all the properties of photons. Photon is the particle nature of light. Photon carries energy in the form of packets. The packet of energy is given by HF, which is also hc by lambda. After substitution, you get it as 1240 electron volt, where lambda is in nanometers. This is the energy of the photon. Second thing, and photon, since it's a particle, it also has momentum, but the momentum formula is obviously not mv. And by the way, the energy formula for a photon is obviously not half mv square. Keep this in mind. And the momentum formula is nothing but h by lambda, which is also energy of that photon divided by lambda. Oh, sorry, not lambda, c. Divided by c. This is the photon's momentum. Photons, when they hit something, they will transfer momentum. They can also supply energy. So momentum and energy is always conserved. Photons are chargeless particles, so they will not be affected by magnetic or electric fields. Keep this in mind. Bye-bye, Mr. VG. Okay. Now, after knowing this, let's move to the next part, which is for particles. See, whatever I am discussing over here in this part, this whole thing is basically the particle nature of light. That particle nature is called as photon. The exact opposite now. The wave nature of particle as in mass m. This wave nature is called as matter wave. Matter wave. And the wavelength of such a particle is given by lambda is equal to h by p, where p is nothing but mass into velocity, your standard momentum. That's all. I hope. No, Zener diode is not there, Thalapati. Why not equal to 0.5 mv square? Why? Because photon does not have mass. Mass of a photon is not defined. That's why you can't write m into v also. That's the reason, Prem Kumar. So these formulas are only applicable in particles. Not many people know that. I think, momentum is h by lambda, momentum is m into v. Then suddenly one day I asked, why you don't use m into v for photon? And people get confused. Oh, then the correct answer is mass is not defined. That's why the formulas only are different. Keep this in mind. Okay. How does the intensity vary with the width of the slit? Asiya Hajit, it varies proportionally to it. If the width of the slit is more, intensity will be directly proportional. So if it is 2 times, intensity will become 2 times, 4 times, 4 times. That's all. Photons is not massless. Photons mass is not defined. It is not defined because you cannot find a mass at, you cannot find the photon at rest. Yes. Is it square or not? No. It's the amplitude which is the square. Intensity is proportional to the square of the amplitude. Intensity is proportional to the width of the slit. There is complete difference in that. Okay. Now having said this, the energy of a particle, this is half mv square. Keep this in mind. This is half mv square. Lastly, momentum, I just told you. Okay. Now, if you want, you can write also this energy, which is actually kinetic energy. If you think about it, it's also p square by 2m. You can also write p is equal to root of 2 times m times kinetic energy. It's one and the same thing. So you can replace it. You can substitute it here, and you can also write lambda in terms of kinetic energy as well. That is also an option. Many times you might have to substitute. Last thing over here is all about accelerating a charged particle. So if you take a charge and if you accelerate it by voltage difference of delta V, then it acquires kinetic energy. That kinetic energy which it has acquired is the charge into the voltage difference. Keep this in mind. So sometimes you can have questions where voltage difference is given and lambda is asked. Voltage difference is given and lambda is asked. Prem Kumar, P's unit is just like your momentum, kg meter per second, nothing more, nothing less. Okay. And so think about it. If I substitute kinetic energy here and if I substitute momentum over here, then over here, what do I get? Observe, lambda in terms of voltage difference. Now, best part is many times you don't have to substitute all the values for an electron. So, if you substitute Q into delta V here, this value substitute here, you will get some big expression, but there is a very easy way of doing it, 1.227 I guess, divided by root of delta V. So, this is the formula which you can remember directly. This is the formula which you can remember. Okay. So, if it is not visible, if it is not visible, lambda is equal to 1.227 divided by root of delta V. This can be a direct formula. Yeah, this answer is in nanometers. So this substitution which I have done will directly yield this result. Photon is the particle of light. Photon is having a quanta of energy. Quanta is a value whose multiples you will get other quantities. Like money is also in quanta, 1 rupee, 2 rupee. The quanta of money is 1 rupee. It's the smallest quantity, which every other thing is a multiple of. Okay, 1.227 is it 12 point? Oh ho 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 ho. Oh ho ho ho. Oh ho ho ho. Sorry guys. Just check it in NCERT. Is it 12.27 only? Yeah? Yeah. Just check this out. 12.27, I think it is for not nanometers, it is for Armstrong, right? Just check it out. Is it for Armstrong or is it for nanometers? Just check it out. So what I had written was correct only, I guess. 1.227 nanometers. It's fine. Yeah, for Armstrong, yes, it will be 12.27. Just like here, it is 12400 when this is in Armstrong. So that zeros get changed. Here also, it is for nanometers. Zenboard, there is a formula, but you don't have to remember that formula. Solve it separately by finding image for the first lens, then the image for this next lens, and then finding the heights. Else you might get a wrong answer because that formula only works when the distance is small and other things. Okay, cool. So this is for your this thing. Now let's go to photoelectric equation. The entire process of photoelectric effect happens via, the energy of a photon getting into removing that electron. So to remove you will need phi, and the remaining is used in kinetic energy of the photoelectron. This is the main equation. Now this energy is obviously HF or HC by lambda. This is nothing but again HF naught or HC by lambda naught, and this over here is just charge into stopping potential. This is your stopping potential. So this becomes your photoelectric equation. Conservation of energy, exactly. Yes, Alpha Press. Okay, is that clear? In some semiconductor, we'll come to semiconductors after a while. 4 graphs which you must know. First graph, intensity and current. That's a straight line. Second graph which you should know is basically your current and voltage. That graph is like this for the same stopping potential. For different intensities, it increases. The next graph which you should know is current versus, okay, wait, I think I need some more space over here. The next graph which you should know is current versus voltage, again, but for different frequencies. So for F1, F2, you will see the Vs values are different. This is another graph. And the last graph is stopping potential versus frequency. And those graphs are straight lines. Slopes are same. Which is just H by E. So these are the 4 must-do graphs for your exam. Is it okay if I only learn these derivations, Mariam? Then you'll get partial marks, na? What about other numericals and all those definitions? So make sure you go through everything. Is that okay? Can we go ahead? Alrighty. Now, radius, velocity, energy of hydrogen atom. This is Bohr's theory. Now in Bohr's theory, you should again remember the postulates. There are some 4 or 5 postulates which you should know. And you should also know the disadvantage of Rutherford's theory and what did Rutherford's experiment prove. All these pointers I have given it to you in the previous class. So Rutherford's experiment, told that the mass is concentrated at the center, it is positively charged, electrons revolve in orbits using centripetal force provided by electrostatic force, all of this. Disadvantages, it could not prove hydrogen spectrum, it could not convince on why the electron does not fall inside the nucleus, it did not talk about the energy levels, all these things. Now Bohr overcome all these failures of Rutherford's model and he gave some postulates. First, the electron revolves in circular orbits using the electrostatic force of attraction, and that's how it performs uniform circular motion. The second thing which he told was there are not many orbits in which an electron can revolve. There are some stable orbits. These stable orbits are the only ones where energy is confined, fixed, energy does not increase or decrease. That's why the electron does not fall into the nucleus. They are called as stable orbits. Now these stable orbits, you will notice that the angular momentum is quantized. It's integral multiples of h by 2 pi. That's the next assumption which he made. The next assumption was all about when an electron jumps from lower to higher or higher to lower orbit, then it involves an absorption or emission of a photon. If it jumps up, it absorbs a photon. If it comes down, it releases a photon. This is what it is. Okay, I hope this is clear. So using these theories, let's derive those formulas. It's simple. I'll just show you the main steps. Rest all things are very laborious and boring. I'll not go through it. So first is using Newton's laws of motion, UCM and Coulomb's law. Just remember these words. So Coulomb's law, Newton's laws of motion, UCM and Coulomb's law. So according to this, the force of centripetal is mass into centripetal acceleration. That's your Newton's law. And centripetal acceleration is nothing but v square by r. Coulomb's law is over here. That is 1 by 4 pi epsilon naught. The charge at the center, it's a hydrogen atom, it is A. The charge which is revolving is also E, but minus sign. Mass is m. Mass is m. It is moving with a speed of v, and the radius of that orbit is r. Radius of the orbit is r. So it will be nothing but force of attraction. What is it? K q1 q2 by r square. Solving this, you shall get r because one of the r goes. So take r on the top. So we'll get E square by 4 pi epsilon naught mv square. I don't know v, we can figure it out later on. How? I'll tell you. The next thing you should know is quantization of angular momentum. So quantization of angular momentum. That's all that is needed for the entire derivations of all these things. So we know that L is nh by 2 pi. H is Planck's constant, pi is pi, n is principal quantum number. First orbit n is 1, second orbit L shell, n is 2, and so on and so forth. Angular momentum is mvr. This is equal to nh by 2 pi. Now from this, r is equal to nh by 2 pi mv. Here also r I am getting. So you can solve them together. That's all. Equate the r's, you will get E square by 4 pi epsilon naught mv square is equal to nh by 2 pi mv. V cancels. From this you will get what is it? 2 pi m e square divided by 4 pi epsilon naught m. This v has gone on the top. N and h will come below. This is what you will get. Simplify it. From this you will get velocity is inversely proportional to n. What will you get? Velocity is inversely proportional to n. That's all you should know. Is that okay? What if instead of momentum energy is quantized? Energy is also quantized in a way, but in a very different way in terms of photons, and the world will be a very different place. Okay, in which chapter is it easiest to score according to my view? I feel it is easiest to score in modern physics, right? That's what I feel. And semiconductor is theory, 7 marks. If you know the theory, you will get a lot of marks over there. Alifa, we have doubt sessions on the Vedantu platform on YouTube. It is very difficult to regulate it. So we have systems channels, we have class teachers, assistant teachers, models in which doubts can be solved for all the students, no matter how big the class is, with the master teacher. So we have that going on right now in the Vedantu platform as we speak. Okay, now once you get this formula for velocity, you can also, what you can do is take this velocity and maybe substitute it over here. From this you will get r proportional to n square. So you will also get the formula for r. Is that okay? Yeah. Okay. Now I left out z, but you can put z also if you want. Yes, that's okay. So this is the derivation for hydrogen. If it is helium, then it will be 2e, and so on and so forth. So you can put a generalized term called as z. In boards there is no z. That's the funny part. That's what it is. Okay. Now going to the next part, which is energy. So total energy is the kinetic energy plus potential energy. Kinetic energy is half mv square. Potential energy is minus 1 by 4 pi epsilon naught charge into next charge, which is Why I put minus sign? Because one of the charge is negative. That's why minus sign, divided by R only. Now the catch is that, look over here. From the previous slide, you found the value of R, right? So you substitute the value of R, substitute it from before, and look at this. Velocity, do you see it right over here? Velocity, we found it. So substitute the value of velocity. Solve it, you will get some terms, but what is important is that n square will be below. So basically it is inversely proportional to n square. This is what it turns out to be. Very, very important. Bharat, it is called as the Pathfinder series. That is the last year. This year, what we might call it, we have not yet decided. But please start watching the 12th Pathfinder series detailed class. Don't rely on one-shots because you have 1 year. So usually my advice is, please don't watch one-shots. So you will see a lot of YouTube videos with one-shots have very good views. But you see the long-term lectures, less views, relatively. Be it any channel, not just our channel, any channel. That's the reason why many students don't get good marks. I understood. Not many students get very good marks. So that's the problem, because students want to do everything fast. Instant Maggie 2-minute noodles. Okay. Anyways, the formula which comes out over here, if you find out the value, it's minus 13.6 by n square. This is an electron volt. Also keep this in mind that the potential energy is twice this energy, and the kinetic energy is just the negative of the total energy. This is also very important. So you don't have to remember separate formulas for kinetic and potential. Keep this in mind. Everybody fine? R naught and this value. So see, R naught is nothing but, or rather I will put it like this. 1 second. R is equal to 0.529 times n square Armstrong. 0.529 into n square, or 0.53 Armstrongs. Similarly for velocity it is 2.2 into 10 to the power 6 divided by n. This is in meters per second. This is what you should remember. Is that okay? I think I had given it before. Okay. How de Broglie explained Bohr's second postulate? So that is not there, Thalapati. That one last diagram which is there in the NCERT, I think like this. It is only for JEE advanced level. That is not there. That is not in syllabus. Ignore. Okay. It's got to do with standing waves and how that wave completely fits in that orbit. Can we move ahead? Sir, will we be expected to deduce the formula for U is equal to 2E, or can we just use these formulas? Ishwar, if it's a question which says what is the kinetic energy of the electron in the second orbit, directly use this. But if it says derive the formula for kinetic energy and potential energy of an electron in Bohr's atom, 3 marks, you will have to substitute. If I was smart, I will not choose that question. Why? So lengthy it is. Waste of time. Instead, I will see what the other option is. Now, if I do not know that other option, then I will do it, because I know I will get it. I will waste some time, but I will get it for sure. So, you choose wisely. Don't choose lengthy options. Time. Yes, it is important, Ajay. I mean, what if you are not left with options? Wow, now we just have your mind maps for nuclei. So nuclei, what are the important topics? So guys, I have given everything that you need. You need to know the size of the nucleus, the nuclear parameters, mass defect, the nuclear force, binding energy, nuclear fission and fusion. In each of them, you need to know the following. So, size of the nucleus, you need to know the radius, the density, atomic mass unit, what happens when Z is same, what happens when number of neutrons are same, what happens when number of total nucleons are same, these concepts. Mass defect, you should know how does, so basically the concept of mass being destroyed creating energy or mass being created destroying energy, and the relationship which is E is equal to mc square, and then the concept of nuclear force which is extremely short range, more powerful than gravity and electromagnetic force, and it acts between any kind of things like proton, proton, neutron, neutron. It does not depend on the charge. Binding energy which is dependent on the mass defect, and the calculation of binding energy per unit, per nucleon, the Q value for reactions, and the difference between fission, fusion, why fission occurs, why or how does fusion occur, and how is the stability affected by binding energy. So all these are important pointers, you should go through it. So for that I have put up this chart right before you. Check this out. All the formulas right in front of your eyes. My name is Shreyas. No derivation in nuclei. Yes, Janaya studies no derivation. Now nuclear force says shows saturated property, meaning that what happens is like if you say electric force or gravitational force, if you separate the distance or separate the masses or charges, the force slowly goes away. In nuclear physics, it's not like that. If there are two particles, proton, proton, neutron, neutron, when you separate them, the force, let's say, it will go off. It's there, it reduces, gone. Suddenly, sudden drop. So that's why it is saturated in a small region. Okay, the map is epic. Now this is going to give you all the concepts. You should know this graph, the binding energy per nucleon. This also tells you this is stable. Binding energy means the energy which is, now this is one common doubt between, for many students, what's the difference between binding energy, what's the difference between Q value? How many of you have that doubt? Or how many of you know the difference? Okay, understand this. See, when I talk about binding energy, think of formation of the nucleus. Formation of the nucleus. When a nucleus is formed, it is made from neutron, proton, neutron, proton. When they collect and form the nucleus, the energy released is called as the binding energy. So it is in the formation of a nucleus from proton and neutron that there will be some mass difference. That mass difference creates some energy, delta mc square. That is your binding energy. But Q value is not for the formation of nucleus. It can be for fission or for fusion. Two nuclei combine to form another nuclei. A nuclei decomposed into smaller nuclei. There will be some mass difference between the products and the reactants. You take the difference, multiply it with c square. Mass difference into c square. That gives you Q value. So Q value is for fission or fusion. Concept wise it is same. It is energy which comes out of the mass defect. But the mass defect arises because of what process? Formation of nuclei or fusion fission. That decides whether it is Q value or binding energy. Is that clear? Okay, just keep this in mind. Binding energy is just, okay, just keep a note of this graph. Also, you should know what is AMU. 1 AMU corresponds to 931 mega electron volt. Just keep a note of this. Know the fission fusion reactions, at least one example. Especially for that uranium, hydrogen combining into helium, uranium U-35 making bombarded with a neutron, becoming unstable uranium, and then decomposing into its daughter nuclei. You should know it. Okay. So Selva Karthik, the graph of that potential energy versus distance is like your, molecular bonding. You would have learned that in chemistry. When two molecules come very close, then they repel. When the two molecules go very far, they attract. There is an equilibrium distance. That graph which is there is exactly the same. It's exactly the same, but instead it is for two inside the nucleus particles. So if two protons come very close, the potential energy increases. They will not like it, they will repel. If two protons go away, they will again attract and they will again come back. So it's similar to that. Okay, parent and daughter. See, parent means reactant, product means daughter. Be it fission or be it fusion. Two hydrogen combine to form helium. Hydrogen parent, helium daughter. Okay? Uranium decomposed into barium, cryptium, whatever. So that initial uranium is parent, the products are the daughters. Okay? All the chapters graphs are important. I don't think there are graphs in your ray optics except for the minimum deviation one. Okay. So yes. So Q value decides whether it's endothermic or exothermic reaction. So if Q value is positive, that means energy is coming out. Energy is coming out. And if Q value is negative, that means energy is being sucked in. Keep this in mind. Alright, is this clear? Yeah, you should know this formula for radius also, R0 into A raised to 1 by 3. What's the value of R0, guys? Come on, let's see how many of you, yeah, no sons apparently. Yes, Nikki. So let's give daughters also a chance. Everywhere we talk about sons and guys and men. So yes, I'm so happy that even the daughters have a chance over here. 1.2 femtometers, very good. FM, 10 to the power minus 15. Okay. I'll be taking a session tomorrow, Sayed, definitely. Now, this graph will definitely help you. Now in semiconductor, how are you going to quickly revise? Notice this. You need to know energy bands, PN junction formation, semiconductor as a diode, diode as a rectifier, special applications of diode. This is your mind map, and in each of them you should know these concepts. This is your mind map. Revise in your head. Let's revise together. Come on, guys. Let's do this. We are coming to that, Siddiqui. Okay. So timing for tomorrow is 7:30 only, I think. Just check it out. I think it's 7 or 7:30, one of them. Be there. Just check the schedule. It should be there in the upcoming sessions also. Now, energy bands. Band formation. There are two kinds of bands. One is called conduction band. Second is called valence band. Okay, it's 7 o'clock. Thank God. You know, guys know it. So two bands. Conduction band, valence band. What is the meaning of valence band? Valence band are those bands which are completely filled. Conduction band, they are not filled, empty, okay, or half filled. Like in sodium, it's half filled, right? All the energy bands are drawn at which temperature? Room temperature or 0 Kelvin? Come on, guys. Think. All the energy bands are drawn at room temperature or at 0 Kelvin or some other temperature. 7, the Dhoni number. Atomic spectra, Shravana, just go through it, the spectral lines. It's only there qualitative wise, the formula is not there. Yes, it is always at 0 Kelvin. Correcto. Now, having said that, if the conduction band has some electrons at room temperature, why it has some electrons? Because of the thermal energy, the electrons go up, then the solid becomes conducting. And that band gap difference is called as the band gap. And if this band gap is less than 3 electron volt, it is semiconductor. More than 3 electron volt, insulator. It is very difficult for it to jump. And if they coincide, merge, it is called as a conductor. Yeah, and that gap is also called as the forbidden energy gap. Keep this in mind. Okay, let's revise this quickly. Next thing. When you increase the temperature of a conductor, resistance increases because collisions increase. But for a semiconductor, when you increase the temperature, more electrons enter the conduction band, and that's why the resistance decreases because it becomes more conductive. Okay. Now, semiconductors can be intrinsic or extrinsic. So we are going slowly towards the types of semiconductors. Intrinsic is pure, extrinsic is impure. Like germanium or silicon forming 4-4-4-4 bonds everywhere, that's a pure semiconductor. Conductivity happens because of the formation of holes and electrons. What is hole? I'll come to ripple factor, Prem. Hold on. Yes. Intrinsic semiconductors, what is hole and what is electron? Yes. Electron is that free electron which moves around. Hole is the absence of the electron. And the concentration is same. Ne and NH. Holes and electrons are same in number in pure or intrinsic semiconductor. You add some material like phosphorus, okay, or antimony, that's pentavalent. Pentavalent impurity, 5, one extra electron, what will it do? It will create one excess electron, and if you put more pentavalent impurities, it makes it n-type. Correct? Okay. Now, in that same structure, you put trivalent impurity, like aluminium. Right? So what happens? One electron is less, it creates a vacancy, it creates a hole. That makes it p-type of semiconductor. That's what it is. When you add pentavalent, make it n-type, pentavalent n-type, you create a donor energy level between the conduction and the valence band. Valence is here, conduction is here. You create a donor level energy in between, which makes it easier for the conduction to happen. But if you make it p-type, you create an acceptor level energy, which makes it easier for the electron to jump to a smaller energy level. Transistor is not there in the syllabus. Very good. Excellent. Now, having said this, the concentration of electron and hole, the product, what is that product? Come on, let me know in the chat box. Ne into NH, the concentration of electrons and holes is equal to, I'll come to that, Ajay, hold on, just give me a second. What is it? Ni square. What is Ni? It's the concentration of holes and electrons in an intrinsic, that I stands for intrinsic, not doped. Very good, it is Ni square. Perfect. That's what you should know. Now let's go to p-n junction. Visualize, everything you have to visualize. Don't go through the books. See, I'm making you visualize. Now you're slowly remembering it. You might be keeping your books in front, but that's okay. But try to think, try to analyze. p-n junction, p-n junction. P has holes, n has electrons. P has holes, n has electrons. When they combine, when they join, the electrons jump from n to p. When electrons jump from n to p, n will become what charged? P will become what charged? When electrons jump from n to p, because n has electrons, p has holes, need is there, supply is there, demand meets supply. So n will become positively charged, p will become negatively charged. Yes, n becomes positive because electrons leave it, p becomes negatively charged. So what will be created? Field will be created. Between what? p-n junction. This process of the flow of the electrons from n to p, electrons are flowing. This is called as drift or diffusion. This is called as diffusion. Very good. And that current which is created is called as diffusion current. Obviously the flow is opposite because current flows opposite to electrons. Okay, that is called as diffusion current. Because of this electric field, there will be something created. Something is coming. What is this coming, guys? Come on, visualize this. What is coming? Because the electrons are jumping, electric field is created. Something is coming between them. Something is coming between them. What is it? Depletion layer, potential barrier. A potential difference created, barrier is created. Barrier is created. So it will prevent the flow of the electrons. But the electric field which is there, that will apply a force on the electrons in the exact opposite direction. The electric field which is there, it will apply force in the opposite direction. So that will make the electrons flow from p to n, not n to p, p to n. Electrons flow from p to n, p to n. That current is called as drift current. Drift current. Correct? See, mind maps are so important. It's very important you make these kind of notes. Okay, let's go ahead. In an unbiased p-n junction, diffusion and drift are equal or not equal? Diffusion and drift are equal or not equal? They are equal. So the net current is 0. Okay. Now if you bias it, let's say forward bias, you forward bias it, then which current exceeds which current? Equilibrium is established in unbiased, correct? If you forward bias it, then which current is more? Current will flow from p to n, that means electrons will flow from n to p. Electrons flow from n to p, that is diffusion. Yes, diffusion. Think logically. Forward bias, the current flows from p to n. That means electrons flow from n to p. N to p what flows? Diffusion. So diffusion is more. In reverse bias, In reverse bias, it's exactly opposite, that's the drift current. But drift is very small because the drift happens only in the depletion layer. Where does drift happen? In the depletion layer. In depletion layer, it's a small region. It's not the major part of the semiconductor. So hence, the current is also very small. Current is also very small in the reverse bias. In the forward bias, the current is very large. Now, a device which conducts electricity only in one direction, not in the opposite direction, such a device is called as an device which conducts electricity only in one direction, not in the other direction, is called as, what is it called? It is called as diode. No, it is not rectified. Diode. Remember, our heart also has a diode. It flows, the blood flows only in one direction in those particular walls. Diode. Current flows in one direction. There is very little current. That current is called as leakage current. Very little current in the reverse direction. In the forward direction, the current flows, but only after a peculiar voltage, unless it's an ideal diode. Ideal diode does not have any kind of barrier. Ideal diode does not have any kind of resistance. It conducts very easily. But no such diode exists. Germanium diode and silicon diode need certain voltage in the forward bias to make it conductive. For germanium, yes, that is called as the knee voltage. For germanium and silicon, the voltages are 0.2 and 0.7. If you get confused which one is for what, I remember it this way. Silicon, 7. Got it? 0.7 is that minimum voltage after which the forward voltage, the diode in the forward bias begins to conduct. Okay, keep this in mind. And for germanium, it is mentioned as 0.2, but in many other books, it is given as 0.3. You will write it as per NCERT, you will put it as 0.2. Understood? Very good. Excellent. Moving on. Now, you should know the IV characteristics. Very important. Okay, that leakage current in the fourth quadrant, and then it goes in the first quadrant. You should know fourth and first. Now, applications of diodes. Half wave, full wave. Now, rectifier. What is rectifier? Rectification is the process of converting dash into dash. RK Gupta, I didn't reply, is it? Yeah, yesterday I did not reply because I was exhausted, I slept, and that's all. I'll reply today, hopefully. AC to DC, very good. Half wave will rectify half of that wave. Upper half, lower half. Lower half gone, upper half only goes. Positive cycle. How many diodes are used in half wave rectifier? Only one. Only one. Only one. Only one. Only one. Okay? Okay. And if the input frequency is 50 Hz, output frequency for half wave rectifier will be how many Hertz? Input frequency is 50 Hz, output frequency will be? Yes. Yeah, the name itself explains it. Yes, surely RK Gupta will explain. 50 only. Full wave means two rectifiers, but there is one common line. Remember, two diodes in the same direction, they come like this, and there is a connection to the central tap transformer. That is a full wave rectification, and in full wave rectification, if you give input signal of 50 Hz, output frequency will be 100 Hz, twice the input frequency. But the frequency, the output which comes is not proper, it is varying. So you collect a capacitor or a filter to make it more smoother. So you reduce the ripple effect, that's all. Now there are three more applications of semiconductor. LED, photodiode, solar cell. LED, light emitting diode. So show a diode, show two arrow marks coming out, that's the symbol. LED, where is it used? Bulbs, TVs, indicators, to show something, warning, whatever, bulb, light. It is very efficient, it is very cheap, very easy to fabricate. Also, it is monochromatic light. LED works in forward or reverse bias? No, burglar alarm wrong, Ajay. No, not in burglar alarm. Burglar alarm, you'll use sound. Burglar alarm is second thing, photodiode. Be careful. It is forward bias. No, not reverse, forward. Guys, made a mistake. Forward bias. It will just conduct normally. Lot of current will flow. More current means more light or less light? More current means more light or less light? More light. Yes. Okay, forward bias. LED, it gives light. It gives light. Forward. Forward. Gives forward. Photo takes reverse. Repeat. LED, forward, gives. Photodiode takes light, reverse. Photodiode is conducted in reverse bias. Photodiode absorbs light, conducts in reverse bias. Based on the light, the current changes. Since it's in reverse bias, there will be leakage current, obviously. Leakage current. So, leakage current is small. So, if the light changes, the leakage current will change, and to observe the difference, it will be very easy. That's why, you use photodiode in the reverse bias. There is a give reason passage, go through it. Give reason. This can 90% come in tomorrow's exam or day after tomorrow's exam. Why is it used in reverse bias? Not in forward. Forward bias, it's so high, you will not notice the changes. And uses burglar alarm, motion detection to detect the intensity of light, to turn on and off alarms based on the light. So many applications are there. Last one, solar cell. No bias. No bias. Yes. There is a construction diagram. The layers which are given, go see that diagram, write it as it is, draw it as it is. Uses of solar cell, everybody knows. But making it is very costly. And all about the efficiency, how it is very useful for the environment, all of that you can write. In solar cell, there is no bias, there is no external circuit, keep that in mind. It itself acts like the battery. It itself acts like the source, it produces electricity. More light, more surface, more current. That's another point. Also, the graph of voltage and current is in the this quadrant, this side. Below the first quadrant, fourth quadrant. Keep this in mind. Okay. Oh, sorry guys. When I told you about the IV characteristic, I just realized now. I told you it is in the first and the fourth quadrant. My bad. It is in the first and the third quadrant. My bad. Sorry. Saying 1, 2, 3. This is 3, not 4. 4 is for the solar cell. Solar cell IV characteristic is in the fourth quadrant. Be careful. EM wave also I discussed at the beginning only. Okay, keep this in mind. So that's it. That is there. Major revision is done, and make sure that you revise with me in the crash course. Me and other teachers are also there. Awesome teachers. You will have assignments. You will have test series. Brilliant way to strategize. Brilliant way to revise. Brilliant way to upscale your preparation for NEET as well as JEE. With interactive classes, doubts. A lot of you have doubts. Whom do you ask? I'm not available always. So make use of the doubt teachers. And obviously the tests which give you awesome report cards. All at the price of $2,700. Link is there in the description box below. If you're already a part of it, or if you're already part of Vedantu Pro, you know what to do. Go ahead, recommend the friends, recommend your relatives, your classmates. Go see Shreyas sir and all the awesome teachers of Vedantu on the crash course of NEET and JEE. Crash course starts on 9th of May, but you can watch the recorded classes till the end, and watching recordings is also sometimes very useful because then you can only watch those things which you needed. Alright, thank you very much guys. And tomorrow I'm going to do most expected sure shot questions, a big session again, marathon types, lots and lots of questions planned, 2 marks, 3 marks, case study questions are also going to be there tomorrow. Yep. Did you guys enjoy? Okay, so leave your doubts and comments in the comment section below. I'll definitely reply because I can see a lot of people are commenting. So maybe I'll have to reply it one by one. Okay, thank you guys. Have your great dinner. Aram se revise. Don't get confused. Don't stay up all night. Sleep well. It's very important. Drink well. Stay healthy. Health is very important. And don't listen to others, don't listen to rumors. I am there for you for your CBSE board exam. You know that. Get your classmates along. Tomorrow we'll rock it for the final session before your term 2 physics board examination. And that's it. That will be the end of physics board wise. But we have a bigger battle to conquer, and that is your JEE and NEET in the days to come. Let's do this, guys. All the best. See you guys tomorrow at 7 o'clock. Bye bye. This was Captain Shreyas signing off. Hasta la vista.